Welcome to 24/7 Flat Earth Discord channel. Be sure to go to VC Chi Check and 1 to get your VC verification tags to get involved in the conversation about our Earth. Be sure to bring your verifiable Earth curvature evidence, though.
Enemy spotted.
Ray Notes Part 5.
Too funny.
Anyway. Is that it on the docket? Wow, that was a short night.
No, you got Ray Notes in here. I don't like him that much because he's a fucking retard. So he's the opposite of how I treat crazy Kason. You might want to talk to Ray Notes. He thinks he's a refraction expert.
He looks like a football. He looks like a football coach. Is he one? He's got an avatar. It looks like he's got those. Are you a football coach?
That's actually me at a soccer game. Yeah, I coach varsity soccer. Yeah.
I fucking knew, dude, man. I'm telling you, I got it tonight, man. I'm telling you, boys.
That was spot
I'm channeling.
on.
I'm channeling something right now. I just don't know what it is.
Anyway, go ahead. Test his knowledge on refract. He thinks
refraction is what I know least about.
The fucking. Yeah.
Oh
go
shit!
Ahead.
You didn't.
Go ahead, Maggie.
Yeah. No, he said that's what he knows least about. So he's already.
Oh, yeah.
He's white flags are coming up, so we don't have to.
You can ask me about it. I'll try to share.
Well, what is it like? Oh, I mean, well, are you first of all, are you a teacher, or what is your?
No, I'm an analytic strategist.
Wait a minute. I've talked to an analytic strategist. Have you been in here before?
I've been here for about a week, I guess.
No, then it wasn't you. There was another person. Me and Gregory had a talk with somebody like that, and they were let's say it was what did he say he was? Not a fallibilist? No, he used another term. Where's Greg when you need him? Now, anyway, but yeah, he was
Jim. I've talked to Elijah, talked to QE a few times, and lengthy conversations with others.
Analytic strategist. So why would somebody that can see the matrix, so to speak, in air quotations, believe that the Earth is a globe? It baffles me. Somebody like you with the numbers and putting things together should already made sense of, like, you know what, this shit don't work out. Like, why would somebody like that? I don't know. Maybe just indulge me on that question, because before I even talk to you about anything else, like, I'm trying to figure this out, man. Like, sound like an intelligent dude, man. Why would you fall for the globe?
Well, it just seems that way to me. I guess when I look at it, it looks that way to me. Like we're on
how? In what way? Like, tell me what about the globe is appealing that you have to say, like, oh shit, yeah, no, you guys are wrong. It's a globe. Like, what does it for you?
Well, like I said last night, I stand at night and I see the stars move overhead, right, and the sun and the moon at various times of day, whatever, and I have a choice to make. Either all of this stuff is spinning around me, or I'm on a platform that's spinning. Well, that's that's where it begins, right? What's the more likely of the two? That the entire expanse of everything that I can see is whirling around me for some unknown reason, or I'm just simply standing on a platform that's turning. To me, that Occam's razor says I'm on a platform that's just turning.
Okay, but
personally.
But I mean, that's just one of the things you could think about. But there's other things that talk about the globe, like, has many inconsistencies. Many of the name, that's probably one to think of what you could be on. Many inconsistencies.
Well, he gave a vehicle. He gave you. Hold on, Ray. He gave you Occam's razor. Why don't we search the mysteries of Occam's razor? What the fuck is Occam's razor?
Oh, tell us.
Well, he's asking you.
He's
asking you, bro.
You better search for that motherfucker quick.
Well, let me see what just comes back from my brain off the cuff.
All right, let's hear it.
Do not multiply entities beyond necessity. That's one interpretation of William Occam's quote. The other more common one, I think, is given the choice between the more complicated or simple explanation, the simple explanation is most often true. That's another variation of a man apparently who lived in what 1100. I don't know. I'm just trying to pull this off the top of my head.
Okay, fair enough. That's a heuristic. I'll give you what you said. Okay, can you now apply it to your spinning stars or spinning globe, please?
Yeah, because if if I'm looking at the night sky and I'm seeing
Mm-hmm.
these objects they seem to me to be infinitely far away. And so all
What
my
the fuck?
Okay.
they look
Yeah.
that way. They look
No,
that
they
way.
don't. No. Wait. Time
To
out.
me,
Can I?
so
You're
telling me
coach.
what
Time
I
out.
look.
No. What I'm telling you is that you're inferring something that has been handed to you. So what you just said was somebody
that's not what I
else's
said.
words. No.
Nope.
What you just said was somebody else's words coming out of your mouth, which is
Nope.
they look like they're millions. Where did that come from? That was not your own thinking. You don't look up at the night sky and interpret the sky that way. Nobody does. You have to be handed these words by some
Did I say
other
million
person.
miles. I
You-
said infinitely far away. Yeah.
Yeah, infinitely. So who said that? Like, why would that even pop in your mind? Like, you couldn't even. There's no reasonable mindset that could. So everybody that looks up at the night sky, nobody says, "Well, they're infinitely far away," and I was the one who thought of it that way. No,
I
that
didn't.
that
didn't say they
rhetoric
were
came
infinite- I did not say they were infinitely far away. I never said that.
Yes,
What did you say?
fucking did.
What the fuck?
I said they
Dude.
look infinitely far
Yeah.
away.
Well,
Yeah.
that's what.
He's an Elmer Fudd sophist. You're gonna. I'm telling you, Mayhem.
This
He's
is
a
about-
fucking retard, dude. He's a double speaking dipshit. But go ahead, because my wife's
What
getting
the
pissed
fuck?
off at me for raising my voice.
I mean,
Yeah.
how far does something need to be away before you can't even tell how far away it really is, right?
What I'm saying though is that you're already thinking about it being far, far away. And how do you know the distance to the thing you're looking at to even infer
don't.
that idea?
I don't
Well
know
then,
the distance.
well then, my thing now is
They
if
seem
you're
far away.
admittedly saying you don't know the distance, then why are you saying that it looking like it's infinitely far away? Looking
Because-
like
Oh,
using
we
your
have-
words.
Yeah, we have 3-dimensional perception, right? So we can see how far away certain things are within our local environment, correct?
Yeah.
So if something's 10 feet away versus 20 feet away, we can kind of tell the difference. You know, if any of us wants to throw a snowball at a friend, if they're 6 feet away
Okay.
versus 60 feet away, you're gonna know roughly how you're gonna get that, because with our eyes, we can perceive roughly how far something is away. Once you get at a certain distance, the 2.5 inches between our pupils will no longer be able to give you any usable triangulation
So you
information
just-
about
right,
how far
you just
something away is.
Train wreck yourself.
You just train wrecked yourself, dude. You thought the same thing I did, Kiwi. You just train wrecked yourself, dude. You don't even know it. You just shellacked your own self right there. You know how?
No,
right?
I'm listening. Yeah, tell me.
You just finished telling us that something's going to lose its visible position from your eyeballs if it gets farther away from you. Well, how then are you looking at the night sky and saying those stars looks like they're infinitely far away? If by but you just admitted that the farther away it gets, you're not gonna be visible to you. So there you go. You just train wrecked yourself.
Because there's two things. One is I'm
What?
telling you
Yeah.
personally, right? Me. I'm telling you they look that way to me. Plus, nobody's went up and caught one. No one's ever grabbed a star out of the sky and brought it back down so we can
But
see one.
by you
Because
admitting that
there's other factors that are
I don't
involved
care
into
about that
why
because
they're distant.
you just admitted that if something gets far away from you, it's not going to be visible anymore. So then how are you going to
No,
put
I
the
didn't say it
stars
wasn't
at such a
visible. I didn't say
No,
it
you
wasn't
said
visible.
that.
No, I said
Now 2.5 inches from your pupil, Meggie.
It was that he couldn't perceive how far away. Not that he
Yeah,
can't see.
2.5 inches
Well,
from his
you could-
pupil, Meggie.
looking like it's infinitely far away. That's the stupidest
Doesn't
thing anybody could ever make up. That's just made up shit.
fair
dude.
enough.
That's made
fair
up.
enough. Fair enough.
Right,
yeah.
but you're saying Occam's
enough.
razor because we're going back because we're scrolling back. We're just peeled back what we just said all the way back to your premise, right? Which
Okay.
Occam's razors, because we're talking about looking up at the night sky, right? And having this base assertion that you're claiming stuff looks infinitely far away. And what I'm saying is, who told you that shit? Or did you just make that shit up? Because, well, how do you know? And that's my question to
don't
you.
know. Didn't
Well,
say I
then,
was.
wouldn't that
I
be the most honest answer right there?
Because
Huh?
you asked me why I think
Wouldn't
what
that be
I
the most
thought.
Ray? But you just admitted what I want everybody to say. I don't know. You just admitted it, just like I know you would.
You didn't
You
ask
gave up
me
the
if I
goods,
know.
bro.
You asked me
You
why
just said I
think.
don't know.
You said why I think it, not why I know it.
Yeah, but like you're thinking what you could think the fucking stars are, lightning bugs or what. Who cares? That's not it. But what we're saying is when you get down to the brass tacks, you're gonna admit you don't know. That's it. and you just did. So why then would you then rely on? Well, then let's rely on Occam's razor to say that it's looks like it's infinitely far away. Why? If you just finished saying I don't know.
Because if they're closer, there would be also a lot of other realities in our world that we would be interacting with. Like we would just go to them and grab them out of the sky.
Nah, that's
Is that
bullshit.
what you're saying?
No,
You're saying
that's
they're
bullshit.
So close we can get them.
No, that's
Let's go
bullshit.
get a
I
star.
didn't say
Let's
that.
go get
I
one.
didn't. No, I didn't say that shit. You went off in a tangent and said that shit for me. You put those words in my mouth. I didn't say that shit.
And you
what
tell
the
me how
fuck
far away
is
a
going
star is.
out and grabbing them? Are you
How far
snorting
away?
lewds?
So you can't get them. So you're telling me they're so far away we can't get to
Are
them.
you snorting lewds with
Yes,
that
I'm
statement?
snorting lewds and asking you how far away they are. We
Why do you want me to tell you something that nobody knows? If you even claimed, no, I don't know. What do you think I'm going to say? Oh, I know. And let me tell you what I know. Why? Because nobody, I'm telling you right now, there's not a living soul that can tell you how far away those stars are. None of them. Not a single, nothing in the sky, not the moon, not the sun, not the stars. And if anybody tells you, they're a fucking liar, like straight out the gate. So, being that the case, that's the case.
That's true.
Well,
That's
then
true.
well, that's great. See how we're coming to the point where now you're realizing that nobody knows. So then, how is anyone gonna look up at the night sky and then declare, well, there looks like they're infinitely far away? Huh?
Some people it will, and some people it won't.
And who cares because nobody knows? That's my point to you.
I
right?
don't know. Then why were we talking about it if nobody cares?
Because that was where we started, where you said, well, I use Occam's razor, and that's why I'm, looking at the night sky. And it's like, yeah, so what? You don't know what anything. You don't know the distance. No one does. So then why are you going to make that inference? Well, it looks like they're infinitely far away. You don't know.
Because in an environment where nobody knows, and that means anyone's guess is as good as anyone else's. And my guess is they're far away.
That's bullshit. You know it, and I know it. That you said that because you just want to say something to top the argument and say I win. No, you don't win.
Of course I did. I'm not trying to lose the fucking argument.
But you should. You should take the L like a true champ. Just be like, look, I got this L because I lost and I don't win because look, I don't know. So nobody knows, man. That's the whole.
Okay, all right, I lost then.
Thank you. And not only that, that also proves that if anybody's out there saying, let's use Occam's razor, well, what the fuck, dude? Because you're not going to be able to get into the next guy next to you is going to be like, well, I think it's closer than you think. It's closer than infinite. And some other guy's going to be like, nah, it's closer than that. Who cares? Can somebody tell me how far away they are? No? Okay. Well, nobody knows. We can just end it there. But
do you agree they're far enough away that we've never actually gone to one or saw one?
Listen, nobody has, man. That's good. That's an easy answer. Nobody has. Listen.
That's right.
But yeah, I don't know if you feel like you won with that one, but that's not a point to be discussing because nobody knows. Anyway, where does that looking at the sky, right? How is that going to get you closer to thinking that the Earth is a globe? Because I try to give you the benefit of the doubt to give me something, right? How does somebody smart as you, be an analytic strategist, now get into this muck in the mire of trying to realize that you don't know shit, and then at the other side of your mouth, you're like, well, I do know something. I can say that what it looks like. No, you can say whatever you want, There are lightning bugs in the sky or whatever. You can say whatever you want. I don't care. That doesn't make it true because people say stories all the time. So we're getting to the brass tacks here. So
all right,
now,
why do I think
now
the Earth is a globe?
Yeah.
Is
so
that
what?
you want to know? Because that was
I do want Ray. I do want to know. But the thing is, if you're being honest with yourself, you're gonna have to answer the questions. How you know, and be honest, right? If you don't know, say I don't know. That's simple, right?
Let's do with something that we can know. Like, let's talk about things that we can know for sure and that nobody can dispute.
That the Earth is not a globe. Let's start there.
All right. So the Earth. Let's start there. So
the Earth's not a globe. Bring the evidence that it is.
Okay. Let's bring the evidence. So if I were to create a triangle between three cities that are, say, thousands of miles apart, and you can make it flat, it'd be a flat triangle. But if I were to choose a city in the middle, so let's just say Barcelona, Spain, Hanoi, Vietnam, and what's the capital of Kenya? It's way down south.
That's a weird city to pick. That's a weird city to pick out of all the
because
cities.
they're far apart, right? They're far apart. So that's all you have to
Nairobi,
do.
man.
They just need to be far apart. So if we take those
Yeah.
3 cities, right? And because one of the things that human beings have been very good at measuring is time, like, and speed and direction. Like we there's no confusion there. We all agree these 2 cities are this far apart, those 2 cities are that far apart, right?
Fucking shit, bro. Go on.
Okay, so here we go. So what happens is if you create that triangle, right, between Barcelona, Spain, Hanoi, and let me grab that city. It's right on the tip of
Nairobi,
my tongue.
mate.
Oh, it's
Nairobi.
Nairobi. Oh, thank you very much. Nairobi, Kenya. All right, so that makes a huge triangle. Now, if you draw a distance from each one of those cities to Riyadh, Saudi Arabia, what ends up happening is that it creates a tetrahedron, basically like a pyramid. Creates a pyramid.
Do it.
There's no way that you can change the shape of that without at least changing the distance between 2 of those cities. If you
What
look at
the
the elevation of those cities, they're only like a couple thousand or a couple hundred meters elevation wise apart. But that the top of that tetrahedron that it forms is something like, let me look at here. I just did the math on this the other day. The top of that tetrahedron is something like it's 4,000 kilometers higher than the other 3 points, and you can't flatten that out. There isn't any
Based on
flat
what?
map based on the distances between those cities,
How do you know those distances?
because people travel between them every day. Are you
Are
telling me that we
planes,
don't know?
are planes measuring devices?
No, I'm not saying that. I'm saying, are you? So you're gonna then prove to me that the distances that I can find anywhere on and
Your
that you can
claim-
find,
Yeah,
prove
he's
to
going
me
for
those
the-
distances are wrong.
yeah. He's going for the triangle, but Ray, were you finished? Like Timbo, I just want to let him finish.
I
what
guess,
he's-
I guess
man.
it's close enough. You guys listen to me.
Nah,
and
you're
fair
right.
enough, fair
I just
enough.
want you to. I just want you to finish. I know. I just wanted you to finish what you were saying, just to
No,
finish it off.
Yeah.
Right. So the point
That's
that
all.
I'm saying is that if you look at the 6 indices that are created by that tetrahedron, or not indices, vertices, sorry, in that tetrahedron, there isn't any way for you to put that flattened out without at least distorting the distances between 2 of those cities. It just isn't possible. And the fact
Okay.
is that you could continue this exercise across
Ray.
those cities and others until eventually you end up with a lattice work of a globe.
Okay, so
You're just
a
doing-
lattice. Wait a minute. A lattice work of the globe. So you can
Like-
work those points. So what you're doing basically is doing some math, right, and geometry.
Math and geometry, yeah.
Okay, so you're combining
That's
math
kinda
and
low.
geometry. You're combining math and geometry to tell you what.
That the distances between those 4 cities creates a 3-dimensional shape. Doesn't prove a globe, not just in isolation.
It doesn't
proves
prove a globe.
but it does
So-
prove that the Earth cannot possibly be flat.
So it
that
proves
if you-
that the Earth is
Now-
not flat.
Proves there it's not flat. But if you continue that exercise by connecting that tetrahedron to more and more cities, eventually, because of the way that the distances between the cities work, it would eventually create a lattice of a globe. It's
A
inevitable.
lattice.
It's inevitable. It
It's
has
inevitable.
to happen.
You've just done a maths equation based on a globe size of what they give us, and then you've
Nope.
then you've put in the distances that they've given you, and you've done a maths equation that comes up with a dodecahedron or whatever you said. You're still
Tetrahedron, yeah.
basing it
Tetrahedron.
on a presupposed globe of a radius of 3959 miles. That's
So
all
when
you've done.
do you
No.
When-
I
Ray, when do you-
didn't do that. There's no radius
Ray.
involved in what I was doing. Just the distances.
Ray,
between the
Ray.
cities.
Yeah, but distances between the cities. You mentioned that like a couple of times already. So we need to figure out though, Ray, is the drop rate over point A to point B on any 2 given points, right? So is there any evidence to provide that there's any drop over distance between any 2 of those points that you talked about?
So, which question am I answering? Is why do I think the Earth is
Mine.
a globe or the drop
No,
point?
the
Well, they're
one that
both
I'm
your
asking
questions.
you.
Well,
The
they're
one
both
that
your
I'm asking you,
questions.
so specifically this one, right? There is a supposed drop over distance on this globe, right?
Mhm.
Between point A and point B on any given point on the globe.
Sure.
So, let's try to see if we can direct, because like, and I'll just say it this way: if I have a sphere in my hand, right, like a basketball, you could measure that drop over distance from 2 points on any point of that basketball. You could say, look, like we could measure what the drop rate would be from point A to point B on any given point on the basketball, 2 points.
Just
let's reframe
it as the.
Are we?
Okay, go ahead. Never mind. I'm sorry. I'm sorry.
You're gonna hijack.
Apologize.
Yeah.
Sorry.
I just don't hijack. I wanted you to continue because I wanted you to hear what you had to say. But like at the same point, I want you to hear what I have to say. So now, if you're taking a basketball and any 2 given points on that basketball, and you were to look for the drop over distance, it's pretty logical that you would be able to find that because we already agree on what shapes are and radius, diameter, circumference. We'd be able to get that measurement out from the basketball easily, right? Would you agree with that much? Just the basketball. I'm only talking about the basketball, right?
Yeah. Yep. I agree.
Okay. Right. So if we're talking about something tangible like the basketball, now we're going to look at something else tangible like the earth you're standing on. So if we live on an oblate spheroid, like they tell us that we are, then it would be easily noted that we can find this drop over distance on this oblate spheroid, just like we did on the basketball. Because 2 points would give us that sagittal in between point A and point B, and we'd be able to say, hey, look, this is what we would measure dropping over this distance and so on and so forth. But what I'm asking you is, you're going the long way trying to figure this out through maths when I'm like, we can just go out into the field and figure out if the earth is actually dropping away from us at a specific rate, which means that from point A to point B on any given point that you were talking about, those distances, those 2 given points, you could find out what the drop rate is, easily negating the fact of having to do these complicated hypotheticals that you're giving us.
Particular the particular math that I gave you is actually quite simple. It's just simple Euclidean
geometry.
No,
it was hypothetical, wasn't it?
The distances between those cities are not hypothetical. They're well known.
What I'm saying is what you were proposing is a hypothetical scenario, was it not?
No, it's an actual real world
somebody's
example.
actually done that. Did somebody do that?
Yeah.
Okay, who
measured
who has done what you just said? Who? Not some. Don't give me a vague. No. If you make this, listen. If you start making claims, I'm going to ask you for specifics. So who has done what you just claimed has happened to create that?
I did that. I did the math myself.
No. That's not what I'm asking for. Because there's math, and then there's going out into the field. I'm saying who went out into the field and tested what you said to be true? Who?
People who travel to those cities every day.
No. I need names because we're going to charge them with that. So who? Give me names.
So you're saying no pilots or truck drivers?
That's not what I'm saying. I'm asking you for that.
You're not giving it the name of pilots, right?
No. Listen. Yeah, that nervous chuckle means that you're coming to the point where you're not giving me what I'm asking for, which is who has actually done what you just laid out for me for like about 2 or 3 minutes. Who's done that? Who went out into the field?
Distances between those cities. Give me the name of anyone that disputes the distance between those cities.
Ray, you're being obtuse. I'm asking you for something. Right now. Who has done that, Ray?
Are you disputing? Are you saying that the distances between those cities are wrong?
Follow what I'm saying. Listen to the words coming out of my mouth, Ray. Who has done that? And please point them to me. Let me know some names. Give up some names.
I don't have any names for you.
Quickly.
So not quickly right now. Not quickly. What we're getting to right now is that you are making a claim that cannot be verified. Is this correct?
No, I'm making a claim that can be verified.
Okay, so now I'm going to continue with the pressure. You're saying that there is somebody out there, and I'm asking for you to give it to me. You're saying I don't know somebody, and you're double down and saying now there is. So who, Ray?
I said that I don't know a name.
Okay, so then who's done it?
I just said I don't know a name.
Okay, so no name, but who's done it then?
So you're saying that nobody's measured the distance between
No, that's not what I'm saying, Ray. My man, that's what you're telling me.
I didn't say nobody's measured it because we
then who's
cities all the time.
No, we're not talking to listen, don't change the thing that we're talking about here. What we're speaking of right now is your hypothetical scenario that nobody's ever done. Now, you said somebody has. Now, if that is the case, and that hypothetical scenario that you just laid out for me, I want you to point to who it was that actually traveled into the field, not just in some paper that you scribbled on or a computer screen. I want you to point out who went out into the field and tested what you said. Go ahead.
I absolutely 100% refute the idea that we do not know the distances between those cities.
Ray,
We
I
know
don't
the
care.
distances.
That's not
I
what
know
I'm
you don't
asking
care.
for. I don't care about you saying you don't know those distances. It's not about the
I
distances.
know the distances, and so
Ray,
does everybody else.
Great. Good for you. Now let's find out who's actually did the hypothetical scenario that you laid out for me not only about 15, 20 minutes ago. Who's done that hypothetical scenario? I'm not talking about distances. We all know distances. We're talking about the hypothetical scenario that you said would happen that would just lead us to know that the lattice would conform to a globe. Like, how do you know? Who's done that? That's what I want you to tell me right now. Not the distances, because we know distances, Ray.
Pythagorean did it.
Oh, well, can you please demonstrate where he said all of what you laid out verbatim? Because now you've charged Pythagorean with this.
Oh,
Where did Pythagorean lay out?
Misspoke.
Well,
Pythagoras?
you misspoke.
Yeah, I misspoke.
Pythagoras. Pythagoras, right?
Yep. Mm-hmm.
Okay. You've just basically said that he said verbatim what you said, right? Is that what you're charging him with?
No, I wouldn't say that. He definitely knows how
No.
to measure triangles.
So
That's all-
this
that's all
has
I'm saying.
this. So you've just charged somebody with something that has no relation to what you just said. Is this correct?
No, I used basic math. Triangles.
So why did you call in Pythagorean?
Because he was the one that figured out the formulas to calculate that kind of
All right.
Euclidean
So-
geometry. It's very
Right.
basic
So
triangles.
geometry.
It's
Yeah,
not
that's
even
basic.
hard.
That's wonderful. But who has done the field test, Ray?
How do you field test a
I don't know,
measurement?
man. It's not. Listen, it's not my claim. It's yours. And you said, well, if you take, you just called what? Oh, who's done that? You just said, well, if you take distances from these three cities, I'm like, yeah, that's great. You're talking a big game. Who's done it?
So you're telling me that the distance between Barcelona and Hanoi is not 92 kilometers or 99,200 kilometers?
You just want to keep going around in circles, aren't you?
No, because
Who's
you're trying
actually-
to refute
Doing
the
that
principles
anyway.
of geometry. How are
I'm
you
not
gonna
refuting the
argue against
principles of geometry. I'm refuting
I-
your asinine story of
It's
how
not an
you're
asinine
saying
story.
it
It's
is
simple
definitely an
measurements.
asinine story. No,
If you-
because
if
you
you-
are making a claim. You're making a hypothetical claim that something
not.
can be done, and I'm like, okay, all of these this little math trick that you're this little trick that you're doing, who has done it? Because I not only
did
this
it.
isn't Ray.
I did it.
Yeah, no, you
Do you want to
didn't.
know? Do you want to hear the results? Do you want to hear the
No.
results of what I did?
You didn't do it because
But now
I asked
you
you.
don't want to know it.
No,
I did it.
No,
but you
because
don't
I
wanna
asked
know it.
you. Listen, I asked you, Ray, who has went into the field. You say I don't know a name, and if that was the case, what you just
No,
said right now, yeah, Ray, you would have just told me I did it. If
I
at the
did say
beginning
that,
of it,
and you rejected it. I
no,
said that.
you didn't.
You asked
because-
who did the math, and I said I did.
Yeah, I said give me some names. No, not math, dude. The
I'll give you
field
names.
test,
Ray
Ray.
Notes.
You get Ray notes. You get lost in the conversation, or you losing the plot because I'm asking.
Okay, let's
No,
say
let's listen
hypothetically
to
that
me
I went-
because you're not answering my question, Ray. I'm asking for the field test, not the geometry, the field tester of your hypothetical garbage. So you're saying this hypothetical nonsense is providing evidence that the Earth is definitely not flat. So what I'm saying is, okay, smart guy, who's ever went out there and tested it.
Okay, let's just
Okay.
hypothetically say it was me.
No. We're not hypothetically
Okay, then
doing
I
anything.
really did it.
We've
Then I
already
really
we've
did. All you have to
we've
do is
already-
prove me wrong.
No, because
you.
you would have already claimed. Listen, you shellacked yourself in that you should have said that at the beginning. But I gave you the opportunity to give me the answer. Who's done it? You're like, I don't know any names. You should have said Ray Notes, but you didn't do that, did you, Ray?
Notes.
Because if
Ray Notes.
you had done that, no, it's too late for that. You should have said that at the beginning. But see how you didn't have the answer, which means you don't have it now.
All right,
So I'm not
sorry,
going to take your little sophistry here. It doesn't work.
I'm sorry. I don't mean to interrupt. And you are, you got me against the wall, and you're kicking the shit out
Yeah.
of me. I agree with you. But I have to ask Ahmad: is there any reason why I can't post an image in the live chat? Does
I have
anyone
no
know why
idea.
that's-
I'm a mod, but I don't know why.
Are you a mod?
'cause-
Is there something like
yeah.
restricted? Because I haven't been able to post an image in
Hang
the live
on,
chat.
man. Just hold your
Doesn't
horses.
have,
Hold
he
your
doesn't have
horses,
image
man.
terms. Yeah.
Hold your horses.
Just while you're doing that, Miggy, I'll just say Before you were in, Ray, we were talking about a court. Now, if you came into court and you made these claims, do you think that the judge think that that's a reasonable piece of evidence that you've got a hypothetical to prove a
Legally, the
positive?
judge can't make that determination.
He's just going to use
determinations of
his
fact-
sophistry, Timbo.
Yeah.
No, this is
I know,
laws. Something I actually know a little bit about. Believe it or
Nah,
not.
but you're getting away from you're just trying to weasel out.
He asked the question. I'm not allowed to answer it. He literally asked me the question.
Yeah,
it
you're
was
just going to
kind
use.
of it was kind of a question that answered itself. So
Yeah,
Yeah,
the jury decides the facts.
It's rhetorical.
The judge decides the law.
yeah.
You not know
It was
that?
Nice
rhetorical.
one, dude.
Yeah.
Okay, so now that you've Ray won, Flat Earth 0, whatever. You want to feel big on this one, but I don't care. But I want to get back to how you're going to
we go.
present the. Here we go. For what?
It's in the live chat.
What is that? What are you showing me? What is this?
Simple geometry.
Simple geometry. Okay, what is that telling us? What does simple geometry tell us?
It's telling you that Riyadh,
Mhm.
Saudi Arabia resides at a certain level above the surrounding cities of Barcelona, Hanoi, and Nairobi.
Well, thank you
there
to
is-
thank you to Captain Obvious and his faithful sidekick. Duh. Like, why do we need to know that, dude? Like, what I'm telling you
because it
is
can't
something
be
that
flat.
it can't be flat. So you
Cannot
just
be flat.
already said it just can't be flat.
Can't be flat.
Okay. So who says who? Ray, you? You're the one who's
No.
saying that it can't be flat.
Oh no, those numbers that I just posted said
Numbers.
it can't be flat. The
Oh,
math-
so numbers are reality now. Is that true?
well, all right, so you're gonna. I don't know.
I know.
You're gonna say math?
Answer my question, Ray. Answer my question. Are numbers reality, Mr. Analytic Strategist?
Absolutely not.
No. Okay. Well, then why are we talking about it like that? If it's not reality.
Well, because if we can
Mhm.
agree that based on the math and the distances that are calculated in that simple geometry, and that just means it cannot be flat. It's not possible. And if you continue
So-
to do that same exercise, hold on.
Dude.
I'm not done yet. I'm not done yet.
Go
If
ahead, finish.
If you continue to do the math that I just posted, right? If you continue to do that with other cities, connecting them to the cities that I've already done the math on, they're going to keep curving. And they're not going to stop curving. They're going to keep curving until they reconnect on the other side. It's going to
Because math said so, huh, Ray? Because math
Yeah.
says so.
Yeah.
So
I
have
think
you-
it's because
Once again, have you went out into the field and tested that garbage you just said, Ray?
You're saying I'm wrong because I didn't travel to those cities
Answer my
myself.
question, sir.
No, I didn't.
Have
do
you
it.
went?
No,
Thank you.
No, I didn't.
Thank you. Thank you.
quick interjection. So Ray, Ray did it, right? Say he went out and did.
He
most
didn't
of
do
this.
it.
No,
He
just
didn't do it.
Say he
We're
did.
not going to
What-
say it. He
Okay,
said he
well,
didn't
yeah.
do it.
He
We're
didn't
not
do
going to
it.
say, yeah, he didn't do it. There
If
you go.
he were to do it, how do we
didn't.
validate?
He didn't
if
do it. He can't
he-
do it because if he did, he would have already done it. See
He
how
said
easy that was?
He said other
With a
people did it, right?
hypothetical. No, you
Yeah.
can't.
No,
have a
he's
hypothetical
claiming-
with a
nobody- no-
hypothetical.
He's claiming.
No reasonable person
Go
disputes
ahead,
the
Ray.
distances between those cities. No reasonable
Who
person disputes
gives
the distances.
a crap, Ray. Nobody's
Because it
talking
says
about
something.
distances. Nobody's talking about distances. Nobody says you can make a construct out of math. Nobody's saying you can't do that. Nobody's talking about that. That isn't the point. The point here that's in contention that you seem to keep losing the plot on is that math that you showed in the little image or the picture, who's
Mhm.
went out into the field and verified it?
Cartographers, I guess.
Well,
Nice one.
And who? Yeah. So yeah, this is what I was getting at.
Who
is
disputes
how,
it?
How do you know that the measurement?
Who
is
disputes
accurate?
Narnia? Who disputes that Narnia is real? Who disputes that? I can make up.
Everybody.
Oh, I don't know. I can make something up right now in my head. How are you going to dispute that?
You're saying
What?
those distances don't exist.
No, I'm asking you. Once again, you try to. This is what you sophists like to do, right? You like to build up like this kind of argument that's not taking place. No one's talking about that. No one's disputing distances here. We're disputing the fact that your hypothetical nonsense has not been verified in the field, sir. Do you understand what I am trying to tell you now? Has anybody verified Ray Notes, that image right there, to be true on a freaking globe? Yes? Have you? Has anyone?
Who disputes it?
No,
The
that's not the
people-
point.
Listen, the people who are saying if you're bringing forth the Earth's a globe because of mass and all of this, okay, smart guy, who's went out and done that? Who's tested this information in the field?
well,
Who's tested it?
Well, just to be
Who's tested it?
technical here, just to be
You better
technical
be.
here, I didn't say the Earth is a globe because of math. You asked me why I believe the Earth is a globe. I'm showing you why I believe it.
And you're
Because of
saying
math.
because of math.
Yeah, you're believing it because of math. That's it.
Yes, the math is actually quite simple. Even for
The
me,
math.
I hate math.
Listen, yeah, but because based on somebody else's information, you're gonna take their word for it. Oh, I trust the math. Well, good for you. But then somebody else can construct any other geometric shape and say, hey, look, man, this also works in the math too.
Yeah,
Are you gonna
they're
believe it's that other shape?
If it's good, yeah, I'll believe it. You're welcome
Oh,
to come
dude.
up with a
Dude.
better one.
You know, but that's the
Is there
worst
a better
place you
one?
can act. Yeah, Ray. Yeah. The better one is knowing the actual information is either truth or not. Because if it was true, then it would be demonstrated in reality, Ray. That means you could go out into the field and test for it. And on that test would come back for you to be, that's the actual truth. You live in whatever it is you say you live on. But if you go out into the field and it doesn't check out, Ray, then you don't have your little imaginary globe or whatever geometric shape you want to make with math.
Yes, that's right.
Is there
That's the
anything
that's
saying-
where the rubber. That's where the rubber meets the road. That's where it really matters. Not where you're over here thinking that you're so smart because you just like the way the math looks. Good for you. I mean, maybe you have this up in a big poster in your room. Who cares? Like for me and everybody else in here, we just want to know if that shit checks out in the reality outside. Go out, take your little math, go do your little triangle test, goes everywhere you want to go, and then verify it, and then come back and tell us how you done it. Because that was when
fair
you
enough.
actually done. There you go. That's what I'll.
fair enough.
Okay.
Hey, Ray, you say
was
that
easy.
curvature is needed for those distances between those cities to be what they
No.
are, right?
No, I didn't say that. I said they cannot be flat because they can't. It's impossible.
Well,
Oh,
you don't know
curvature
that.
isn't
But you
needed.
don't know that. But you don't know that, Ray.
Actually, I do know that.
No, you don't know that, Ray. Because only with math can you think that that's the case. But when I tell you, Ray, go out and
Correct.
go out, yeah. So when I say go out and test it, you're gonna agree with me. Well, shit, I can't do it. Well, there you have it, Ray. You believe math is reality. That's your stance, and it's not ours.
I
Because
didn't
we're
say
like,
math is
Ray,
reality.
what do you think, Matt? What the math that you're showing us? You're saying,
Just
well, I
give me-
believe yours. Yeah.
Just give
It's
me
giving you
different
what?
numbers. Give me the numbers that makes
Well,
that
you are
flat.
saying math's reality because you're saying that it can't be flat because of the maths.
With
So
those
you're
distances,
saying
correct.
it's your reality.
Uh-huh.
No, hold on.
With those distances, yeah.
That's not what I'm
Whatever
saying.
caveat, Ray, whatever caveat or addendum, I don't care. You can add whatever you want. That's not what I'm saying. I'm saying with the distances, who cares? But it's still math at the end. You got numbers,
Yes.
right? Well,
Yes.
that's the point. We don't, yeah, whatever, dude. Like when you go out into the field and you verify that and come back and say, look, it checks out. The math checks out. When you come back and tell us that, then somebody else can go repeat that and go do it and find out, you know what? Ray Notes is correct. The math does check out. But if nobody's ever done it, then you're just believing it. And
I
that,
don't know.
whatever,
If I
you
have
can,
some
you
free
can.
time. Actually, maybe I can verify this
What
myself.
the hell, man? You're onto something now. Let's. I'm gonna cheer you on. I hope you go have a nice test and go everywhere you want to go. Make sure you do the due diligence that needs to happen when you go do this, right?
Right.
Don't just go out there and look out into the distance and be like, man, it's a globe. Nah, you better not. You better come with all your ducks in a row when you come back over here, because we're gonna quiz you top to bottom on it. So
Well, in this particular case, I guess what I'm imagining is that we can describe three-dimensional shapes using simple geometry and math, right? We do that all the time. I
Okay.
did that here using those distances.
Oh.
So if we can change those numbers, we can definitely make that thing flat. With the
well, I don't
numbers
know
that
what
are
you're
there.
talking about, man. Like you're trying to do something in a mathematical construct and then say, let's change the math by going out. The math is what it is. It's already built
Yeah,
something built.
And he's trying to make us make a claim about those
Yeah,
distances not being
that's-
correct as well.
That is nobody's
Yeah,
talking about that. We're trying to.
That's a pretty reasonable request, I'd imagine.
No, it's not really. What we're asking
Why?
you right
Not
now
our
is
claim, man.
Yeah, we're asking you to verify the information to be what it is. As you say, it's information that leads us to understand with the math that it is a globe. That can't be flat. So, with that being said, that's talking the big game, Ray. And you know about big games, right? Because you're a soccer coach. So, that's the thing. If you're talking a big game, you better back that shit up, man, with some real evidence. So, that's all I'm asking for is this panel, this council is asking for that too.
Well, hold on. That evidence I gave you is real. Now you can dispute what it means. But
Ray,
that
it's
is
math.
real evidence.
It's just math, dude. That's all it is. What is it? Yeah. So, I mean, if I told you,
negative 2 apples.
we're gonna start demonstrating how math is in reality. But yeah, you can't hand me the number 3, can you, Ray?
No, it's not.
Or
real.
are we
It
gonna
doesn't
go out in
exist.
nature? Well, are we gonna go out in nature and find the number 5 just running amok? No, dude. It's
Yeah.
just so right. So math is a language.
So
But-
that's, yeah,
What?
I guess to a degree I agree with that. But we do use it to measure things, and that's what I
Yeah.
did.
So what? But what I'm
You
no,
don't
you
measure
didn't.
with math.
You didn't.
You don't measure
Listen,
with
man.
math.
You
You
didn't
measure
right
with
now.
measuring.
But what I'm saying right now, you didn't do any measurement. You didn't. That's the
No,
honest
yeah, I
truth.
took other. Yeah, that's true. I agree with that. I
All
took other
right.
people.
Well-
I took the measurements that everyone in the world agrees on.
Bro. Like here you go
They're
again.
not
Like,
measurements, they're estimates
Yeah.
anyway. So
That is true. That is very true.
Well, you just keep slacking. I don't know, bro. Like honestly, Ray. Sometimes
Yeah,
you
but-
just got to take the big L and just
Well, hold on.
I mean, but we got a
Just because-
consolation prize for you, man. Like,
no, just
Can I ask
hold
a
on.
question
Hold
to
on.
clarify something? Is that okay?
yeah, go ahead,
Sure, I
AJ.
guess.
I
know,
could be
Ray's-
completely wrong, but you're saying that you use these triangles to measure over that distance. Those triangles form a pyramid, and the more of these distances we do with triangles, these pyramids eventually map out a globe. Yeah, is that what you were saying?
Oh yeah, if you interconnect, if you keep doing the same exercise that I demonstrated above, yes, it would eventually make a lattice work of something that would appear like a sphere.
Okay,
dude-
so then this pyramid would have to, across this large distance, would end up with a square, flat base. So how have you got this square, flat base wrapped over a globe, and where are you getting your horizontal lines for that triangle measurement in the first place?
Woo!
Well, the flatness, the flat. Okay, so let's start with the flat base. So, Barcelona's 12 meters above sea level, Hanoi is 5, and Nairobi is 1795. So,
But what you're
you-
failing to take into account is that drop over distance. Don't worry about height above sea level. We've got to take into account the drop
Yes.
over distance, which is going to give you
yeah.
a curve, not a straight
Ray-
line.
I already
Oh,
told
but
you about
but
that,
hold
Ray.
on. Hold on. Yeah, I can. I already have an answer for that. Just let me answer.
didn't answer
AJ's
me.
question. Well,
Yeah,
just give me a
baseline.
chance. So yeah, there will be a drop over distance. So what if it's on a globe? What would end up happening is that each of those lines, and you can kind of see that in the Google Maps thing that I posted above, that they form kind of an arc, which would make each of those lines slightly longer. But to deference of a flat Earth audience, we could just subjectively say that they're flat because the amount of length of each of those distance created by the curvature is absolutely insignificant to the apex of the tetrahedron.
But that's bullshit,
Oh my
though, Ray.
God,
That's
man.
bullshit, Ray.
Well, if you've got
bullshit.
any curvature at
do you
all
wanna-
in
do you
those
wanna-
lines, you don't have a right triangle anymore. So
I'm not saying
they're
that you have
using
a
right
triangle.
triangles here.
No, but that's
if
bullshit, bro.
if you cannot connect those vertices with using those distances on a flat surface, you cannot connect them.
No. You're
That-
you're
that-
just you're right now. What you're saying is just because you're trying to figure out like how you're gonna reconcile the flat Earth from your mathematical construct. You're going ass backwards. You're not.
No,
You can't do
the
it that way.
The apex that forms is just it's
See?
orders of magnitude
So
higher.
you're
You're
not
still
using
looking
a triangle
backwards.
to measure the distance then.
No, you're
You're
not
looking
using
backwards,
a
Ray.
triangle to measure
You're not
the
using a
distance.
triangle to measure the angle or the distance.
No, you're using a triangle to measure the height of the apex of the tetrahedron. In
Which one,
relation-
man? The one
So
you have
where's the
constructed in your
triangle
mind?
Where's the
Riyadh.
triangle on your
Look-
example here? Can you point out the triangle on your
Well,
example of this globe?
He put it.
like
Let me.
the form of the tetrahedron. If you do the math,
Nah, hang on. Like
apex, which
Ray,
is
not a
at
triangle.
Riyadh.
Ray.
Oh.
You already put the image in the text. I don't know if AJ's seen it or not. That's why I'm trying to stop you guys.
Yeah,
He
I'm looking at it right now. I'm looking for
You
this
find it?
triangle.
Here, I'll
There
get it
is-
for you.
There's it's
Ray,
in
are
a
you gonna
s-
post it or you want me to post it for him?
No, I'm looking at it. There is no triangle. It's all curved lines.
Yeah, I know, but that's
fair
just
enough. Sure. I mean, yeah, they look curved, but
they are. They're not. They don't look. They are.
Look at the numbers that I just posted in there, though. The apex is so much higher. Where Riyadh resides is literally 203,480 meters above.
Why do you keep talking about something
surrounding
that's
cities.
non sequitur, man? Who cares? That's not the point.
Because it's not flat.
If that's the case,
point.
then directly measure that.
Hey, go on, Harrison.
Yeah, directly measure that curvature over the distance if that's the case. If it's there and it has to be there in order to get those numbers that you got, then just measure that.
The question was, why do I believe the Earth is a globe? It's because it cannot be flat, and those measurements prove it.
No.
Beyond a shadow of a doubt. It's like in that, unless you want to dispute.
Okay, it can't be. Therefore, it must be curved, right?
No, I'm not saying it must be curved. He asked
Oh,
me
okay.
why-
Well, it's kind of a
why-
dichotomy. It can't be flat, so it must be curvy, right?
No, he said, why do I believe it's curved?
You're saying that it
because
must be.
of this.
You just said it can't be flat,
No,
so
no,
there
it's
must be a curve.
Why do I personally believe it's curved? It's because it flat doesn't
We're not.
make any
We don't
sense.
care about your personal opinion, dude. We're just trying to figure out what reality is.
And then don't ask me what my opinion is, and I
Yeah.
won't give
Well,
it
your
to
opinion. Your opinion doesn't really matter, just because we're trying to figure out what objective reality is, right? We're not asking what's Ray Note's opinion. We want to know what's
You
actually going on.
literally-
Like,
It's literally what he asked. Why do I think that? This is why I
okay,
think
and you said, given those numbers that you showed us, that the surface must not be flat, therefore must
not
be curved.
No, I said if you repeated that exercise over and over and connected more and more cities, it would create a lattice work that would be definitely look like a sphere when you're done. It would look just like
wait.
a ball.
Hey,
Maybe.
real quick.
Maybe.
Let me just say
Maybe.
something. Let me just say something. So, Ray, I got 2 questions for you, man. Are we talking on Discord?
As far as we know, yeah. I would agree we are. Let's put it that way.
Okay. All right, Ray. Are you 100% sure we're talking on Discord right now?
No.
There you have it, folks.
Ooh.
Ladies and gentlemen of the
Conversation's
jury,
over.
we're done here.
Over.
Thank you so much, Ray Notes. Your goose is cooked.
We can't believe anything if you don't even believe in reality, man.
I'll be here all week. Maybe.
No, we could come to agreement on what we think
So
is 100%
Man,
real.
I thought we
though.
were talking on the internet.
So you can't know that anything is real. Why are you here trying to argue for what's real then?
Well, because what we can agree on is if you can't prove something's false, if you can't prove it's false, then we can discount that. Like I can't prove
Can't
that
prove
we're
a
not just
negative,
brains
mate.
in it. Yeah, exactly. So if we all agree that you can't, if we all agree that if there's no null hypothesis, right? Like if we agree that, then
Nah.
we'll just discount that stuff. Like
We
we'll
can
just
prove that curvature is false.
Your opinion is that you don't know that you live in reality, so everything that you're arguing for is null and void. Sorry, mate.
Yeah, but we can
Yeah.
prove that curvature is false, though. We can see further than we would if it were present.
I don't agree with that
Why not?
because the math doesn't work out, and I did that too.
How does the
More
math
math.
not work out?
Do we want to do this again?
Yeah. How does the math not work out?
Alright.
What's wrong with it?
Oh boy, what is it? It's 10:58 my time. Okay.
Hey, you guys
Go
take
ahead.
your time. I'm out. I'm out, skis. Thanks,
Okay,
guys.
peace out.
It was
Hey,
fun,
man.
man. Later. Hey, what's up, bro?
Okay. Yeah, this is.
Yeah, what math and how doesn't it work out?
What was your claim? You said that why do we see further than we
So
should?
it doesn't sound like you even know what the math is before you're saying it doesn't work.
Just said I was going to show you the math. Why would you think that?
Because I've asked you like 3 times what it is and I still haven't gotten
Because
an answer.
Yeah, because I didn't know the math before, and then I went and learned it.
Well, do you know it now? Okay, you went and learned it.
Yes,
So
now I
what
know
is
it.
it?
Yeah. Okay. All right. So And my beer's almost empty. I'm gonna have to take a break and get a new one.
That's not the
Get
math.
another. Get
Okay.
another one, man.
All right, let's start with the simple. Like, what should the distance be of the horizon? Right? How far away?
1.22 meters.
Well, if you
Miles.
sunk your eyeball halfway into the
1.22 miles.
level, yeah, it'd be 1.22.
1
miles.
foot, man.
Give me the formula. How far should it be according to Ray Notes?
I just gave it to you in the chat.
Okay. What are the numbers? Okay, radius,
Well,
3959 plus height. Okay, so
let's go
1.225
50.
miles.
59's too big. I try to give like flat Earth as much leeway as possible, so I take the shortest radius possible. So I would do 3950, right? That's the pole. That's from pole to pole. So that's as small.
How do
as
you
the
know
Earth
that?
can-
Okay, so you're going to
fuck, I don't
constrain the
know.
distance to the horizon even further. So it's going to be
Yeah,
even less
no,
than
no.
1.2.
No, it's going to be closer, right? Because I'm choosing the smallest distance, right?
That's just what I just said, Ray Notes.
Okay.
If you choose the
Um,
largest distance, your drop over distance would be.
Okay, so
Much
Ray
further
Notes
away,
wants
yeah.
to make it harder on himself. It'll be something a little bit less than 1.2 miles times the square root of the observer height in feet.
So all right. So in this scenario that we're about to walk through, we'll assume that the radius is correct, and I'm choosing 59. What did I pick? I chose the smallest one. 59 or 3950.
3950 you chose.
Yeah.
Yep.
Yeah, that's the one I chose. What I'm doing is I'm saying, well, how far? Because the one that keeps coming up, and this was the one that Elijah brought up the other day, and so it's
Yeah, I just brought it up again. So you just told me that the horizon should be even a bit closer in that picture than 1.2 miles.
Well, hold on.
Where is it?
We're not done yet. So
Yeah, we are. You already gave us the info we needed. We're giving you the geometric horizon formula based off of a radius of 3959. You
Right
said,
there.
no, I want to go a little bit less than that. So it's
Because
even
if
just a
I-
little bit less than that.
The reason why I did that was because I'm giving you the
Who cares why you
closest
did it?
horizon
We see further than the 1.2 mile, the 3959
That's right.
radius.
Well, let's get
we see
there.
further than that. So why do you
we
want
see
to
that?
close it in even further?
To give you guys the benefit of the doubt. I'm helping
What
you.
for? We're
don't
already
need
seeing
it.
way further than your maximum radius.
That's what we're trying to get to. Is why do we see farther than we should? That was the question that you asked.
Because
Oh,
it's flat.
Then we
Well,
should
that's-
based on what? What are you basing what we should see on?
That's what you said. You said that we see a lot further than we should. If the Earth was curved, we should not be able to see as far as what we do see. Obviously,
Well, that's the
this photo
geometry
shows
of
that.
it. You just agreed to it, given
Yeah,
that radius.
I'm giving you the geometry of it, and it does calculate out. So in this particular formula that I just posted, I'm saying this is someone roughly my height, which I'm 6'1", right? So I'm standing on a lake, and I'm looking out. How far should I be able to see? And what I did here was I said, well, I'm probably not going to stand in the water. I'm going to be on the shore. So I'm going to put my eyes at exactly 6 feet, which works out to 1.288 meters. So the distance to the horizon when you run that
3
out,
miles. Yeah, great.
it's 2.99 miles. Yeah, so it's
Oh,
basically
okay,
3
so
miles.
so let's cut to the chase. In the picture that I'm showing, we have a 1 foot observer height. We've got the horizon further than 9.4 miles. So what's your point?
Yeah, so let's figure that out. So why would we be able to see further? So one reason why we might be able to see further is refraction, which we've talked about before.
Yeah, we did, and you need two media for it.
Yes. So, and we can figure
Or
that
we could
out.
grant you terrestrial refraction like we did the other day, and then we could go through those 5 effects again, and you
Yeah.
can try to tell us one by one which one it is.
You won't need to do me any favors here, believe me. So if we begin to figure out what on a particular
You could
day,
also do this. You could also tell us how it was measured in the first place that the Earth has that radius that you're talking about.
Well,
Otherwise, you
I
don't have any globe or any geometric horizon
Um,
to refract.
Yeah, everything
It sounds
after
to me
that
like
is,
you don't want to. Yeah, it sounds like
null
you don't
and
want to
void,
hear
man.
you don't want to hear my explanation.
I don't want to hear the stories. No, I don't want to hear explanations. I want to
Well,
hear
if we don't-
I want to see
right.
demonstration.
Right. So what I'm saying is, like, if you give me the planet's curved, which is what I believe. So,
Okay, go. What equation are you going to use, Ray, for standard refraction? What are you going to use?
well, we have to figure out the refractive index, right? So what we're going to use is Sidor's equation.
No, we have
so
to
you
figure
just
out
got
how
a
you measured
sliding
your.
scale of, yeah. You're just going to
we
use
got- we
a
gotta-
sliding scale until it works? All right.
No,
We
no,
gotta
no, no. We won't
figure
have
out how
to.
you measure the
No, we won't have
geometric
to.
horizon that you say is there, but refract it.
Check
It
this
has to
out, guys. He's going to tell us why it looks flat, even though it's not. He's about to give us the equation for why it looks flat, even though it's not. But he still claims that, because I just heard him claim it, that the horizon is a geometrical position. And then he's going to say, here's the reason why the horizon looks 10 times further than we should actually be able to see it because of Earth's curvature.
So what
in
you're
other
saying
words, you're
then,
saying that
right
I'm
now,
going to
is that
Hold on, isn't that what you're about to tell us? I mean, you're going to say, well, the horizon is, due to these mathematical calculations. I mean, and that's what they've been asking you. I've been listening for a minute. I mean, they're about to ask you, and you were going to say, well, how about this equation, this equation? What equation is going to make
excuses?
It's just excuses. It's just like
Well,
they
let's
gave
get
us the number for the
let's get his
bro.
response.
Yeah, the question was, why do we see further than we should relative to
Wayne,
geometric?
who asked that? Who asked that?
Heretic asked me, why do we see further than
Hold
we
on.
should?
That's a legitimate question, but I don't think that was the exact question asked. Go ahead, guys.
Well, why should we only see 1.2 miles at that 1 foot observer height? Has somebody measured a radius or something that goes with that geometric horizon distance?
That's not my position that we should only see that far.
Okay, so why would
Okay,
we
so
think
you've
that?
got a bigger Earth? Have you got a bigger Earth then, or what?
So you just guess. So you just guess at everything then, and then when the guessing's done, then you actually have to do something realistic. In actuality, then you guess again. Then so the interesting thing about the explanations you're about to give us, as to why everything looks flat, just like Helio said, it not only looks flat, but in every single circumstance, every time we look. No matter how far, it is flat. So I think we're done here.
Yeah, every
That wasn't
instance.
the
I mean, it was
question.
just like
That
all
wasn't
with
the
all
question.
No. Well, whether or not you think it's the question or not, but when you zoom in on something you can't see with a P900, P1000, or a telescope or whatever, and you can see across the horizon, you can see further than. What you're not seeing further, you're just actually with a telescope or a high zoom camera, you're actually just limiting your view and zooming in on something that is already there.
You're just seeing what's there.
Right. So I want to ask Ray Notes something, if I may. Ray Notes.
Can you guys hear me?
Yeah. You were about to do some calculation or something for the Black Swan image, right? Is that what you were about to do?
No, I gave a different. I set it up with as if the observer was 6 foot tall, or their eyes were at 6 feet. That was
Okay,
Sure, and it's about 3 miles. Yeah, we all agree on that. Where the
geometrically, yes. And why would-
geometrically where
the
it
question
should
was,
be.
why should you see further than that?
Sunny go.
That was
Let
the
Sunny
question.
finish.
That's not why I brought it up. If I could get to why I brought it up. So the reason I asked that first part is because how are you gonna reckon with in the same view as the Black Swan? You can see the islands 30 miles away in the same view. What are you going to do about that?
Well, that wasn't the question that was asked, so I haven't contended with that. I'd be happy to if you give me time. I know you're asking me. Have I contended with that? No, I haven't contended with that yet.
Hold on. The only reason I was saying that is because in lieu of you actually doing the work for the Black Swan, or to do the calculations based on whatever, you're making up some new numbers here. We don't need that, but go ahead. So once you get done with that, you have in the same view something that is 30 miles away. That's 3 orders of magnitude larger.
I wasn't. Yeah, I'm not. I wasn't I wasn't dealing with that. I was dealing with Heretic's question.
I understand, but I would keep that in
I
mind.
don't have an answer for that because I haven't. And I'm familiar with what is it? It's a BLMLS B69, right? That's the videos. Those are the Black Swan videos.
Yeah.
I'm familiar with his channel. I'm familiar with the content on it. I have reviewed it. I haven't taken apart any one of those or tried to analyze it just yet. The question that kept coming up to me in this group since I've been here is why if you are standing on a lake that's 7 miles wide, it should have 66 feet of water in between you and the other side. Or why would you be able to see the other side? So I took that challenge and started applying the math to it, and I had to learn a ton of stuff I've never wanted to know.
So while you're taking that challenge, are you begging the question of there actually being a geometric horizon there that you're not seeing?
Yes, he is.
I would
he
be
literally
begging
said,
your
if you just give me the curve. He just said, if you just give me the curve. He literally said that.
So you're begging the question of your geometric horizon that we don't see. We don't see it, and you go, well, it must still be there, but why aren't we seeing it? Is that what you're doing, Ray Notes?
Because what you are seeing is the other side of the lake.
Can I answer? I don't know. The question was to me.
Yeah,
so
yes, please answer that one. Answer that one.
The question was, why do we see further than we should?
The question is, are you begging the question of a geometric horizon in those pictures that we do not see?
Even if I am, it doesn't mean I'm wrong.
Yes or
You
no?
can beg a question and be right. Yes, I could be begging the question,
You're
but
begging the question. Okay.
you asked the question.
Well, usually
you're
you would
begging
know
my
if you're
answer.
saying the words begging the question, you would know if you are or not.
Sonny.
And if I give that to you, like, okay, I'm begging the question.
Okay, that's invalid. We can throw that out. That's a logical fallacy. We can just throw that out.
Hold on.
Hey,
Logical fallacies.
Flatsy's requesting one person talk to him. I think Heretic. I choose Heretic, please. Sonny.
All I'm saying is that logical fallacies don't mean that a person's argument is wrong.
They don't mean that it's right, so we can just throw it out.
No,
it doesn't mean that your premise is wrong. No, it does not mean your premise is wrong, but it means your argument for your premise is invalid.
That's right.
Yeah, but that doesn't mean that your conclusion is wrong. You might have a really
It
stupid reason.
means that your argument cannot get to a true conclusion. So
That's
you
right.
gotta drop that argument.
You don't have a valid logical pathway to the conclusion that you're arguing. So we got to throw that out.
The conclusion could be true, but your argument fails to get to that point.
Yes. Yes.
But if you're asking, but if the question is, why do we see further than we ought to? And so it's the begging fallacy is baked into the question because you're asking me, why do we see further than the geometric horizon if the Earth is curved?
No, you're asking the question, why do you see further than you should on your ball? And so you assume that all light is bending around the ball to hide the effect of your ball. There's no proof of that assumption.
Except for we understand optics and how they work.
Yeah, we understand optics, and we understand that light does not just bend for no reason. And it does not just bend down always like you want.
Yeah, and if you allow me to finish my demonstration, I would show you why it does.
With your little thing here, you're not saying anything that would refract anything because it needs a boundary condition.
Because I haven't been able to finish.
It's the angle to the boundary that matters.
Why would you
assume it's going to bend down? That's retarded.
I'm getting to the. Yeah,
why would we let you finish? Why would we let you finish, Ray Notes? You already admitted to us that your demonstration is based on a begging the question fallacy. Why would we waste any more time on that?
Because if I go back and try to answer the original question, which is, why should we see further than what the geometric horizon indicates we should?
Well, that's easy because there isn't one.
That's one answer. There also, because of the nature of optics, there's another answer. That's what I'm trying to share.
Okay, so that one would be based on begging the question of the geometric horizon.
Yeah, you also have a problem.
Even if you're begging the question,
little man, you have a problem. You started by assuming Earth is curving and using calculations, and when you look at the horizon, which you think is the Earth curving, you compare it with your calculations, and those calculations don't take into account any optics or perspective. They convert that into Earth curve.
Really?
Yes.
Thank you. I know. I'm not there yet. I haven't gotten there yet.
Well, you keep telling
Been
us that you're just
interrupted.
going to beg the question, so why would we waste any more time on that?
Because I don't think the Earth is flat.
So
and
what
this is
you?
a
Yeah, but
mathematical
nobody
proof
cares
for
what
why
you
it's
think.
not.
It's not about your opinion, though. It's about objective reality. So if you can
Right.
show us a measurement of the geometric horizon that you say is refracted, then maybe we can go with you on that. But until then, all you have are logical fallacies, and we don't care. It's a waste of time.
Yeah,
Well, then you would have to.
I'll teach you how to verify your claims. Just take two lasers of different wavelengths and shoot them across a lake that's large enough that both rays shouldn't be able to hit the target because they would refract at different rates. But the military has done this, and they don't
haven't seen that.
refract as the models that most globers use and assume the air is refracting. So it doesn't work. You're nonsense. Not in
Well,
reality.
I'll
refraction
post
works.
the
Refraction works very like we
Refraction is
understand how
not
to
what
measure
you're
that.
talking about, little man. Refraction is Snell's law, and we understand how that works.
We haven't
What
gotten
you're
to
talking
Snell's
about
law
is
yet.
you're
I'm
talking
gonna
about
get
light
there.
traveling through the air, which has no
Mhm.
boundaries, and you require boundaries
I've
for
ac-
Snell's law or
Yes,
refraction.
and
So what
I've
you're talking
accommodated.
about is atmospheric refraction or terrestrial refraction, but you don't know what you're talking about.
Well, don't get
Yeah,
too
you
mad
know what?
about it, but
I know I was going to drop back, but listen, refraction is done with over because, for one, you don't have the you don't. It doesn't. It would have to exist in a static world.
I
That's
deal with that. I deal with that
Well,
in this proof.
oh,
I deal with that.
really?
How? I
Well,
don't know.
well,
We're not even getting there yet.
no, I don't think you do because if you're still saying refraction, then you're still claiming this
Well,
nonsense.
I can't accommodate your lack of imagination for my answers to these questions.
Oh, shut the fuck up! You're going to talk about my imagination? Then
Let's all imagine the Earth as a globe and what it might look like if the Earth was a globe and refraction, the way he's describing it, is real. Then it would look flat, but then it's actually a globe.
Yeah, yeah, and look at this helio, and look at this at the same time, in the same view. When he just rolls the camera up and then zooms out, you can see the islands and then the oil rigs. So now he's got to calculate for two different fractions from two separate landmarks, the islands and the oil rigs. It can't be done. They're just digging a deeper hole.
Yeah, but they'll never see it though. I mean, they won't ever see it in their mind and spirit. They'll never be able to see it. They want the globe to be true so bad, and it's not. I mean, this ain't you, Ray-Ban. Is it Ray-Ban? Ray
Notes.
Ray Nuts. Oh, Ray.
Ray-Bans.
That's a good one. Love that.
Anyway,
That's
it's just like they just want the globe to be true so bad they'll just make up anything and just freaking. It's so weird, man. Why are you being so weird, Ray? Look at the Earth. What is right in front of your eyes? You've been talking about math. Math is on paper, or that's 2D on paper. Well, it's not even 2D. Your pencil's 3D on paper. I mean, the pencil lead on paper is 3D, bro. Fucking
Yeah,
A.
hey Helio. But we got to keep this in mind, Helio, because we're going to ask him now, because he said he's dealing with what I said about it being a static. It has to be static. Everything has to stand still, and it also has to line up so that their so-called density gradient is lined up just the right way. It has to be just perfect every single time. So it has to be a static. So how did you stop the Earth?
Yeah, and if the math's going to fix it, then the math has to be perfect too, right?
How did you stop the swirling of the gases above the surface? How did you stop all that?
I didn't. I gave Flat Earth the most benefit of the doubt in this analysis that I possibly could.
Wait 1 freaking minute. No, you didn't give Flat Earth the benefit of the doubt. I'm telling you something that is objective fact. The gases above the surface are swirling in all directions, omnidirectionally. Is your refraction allowing for omnidirectional movement of the gases?
What's the well? You would have to answer this question then. What is the
you
ratio?
Answer my question first. Answer my question. Is your refraction accounting for omnidirectional motion of the gases?
It doesn't have to.
Yes, okay, why doesn't it have to?
Because the speed of light is way faster than the motion of the gas. Holy
You're
crap.
talking about density gradients raising things
I'm
up
not.
hundreds of feet. Yes, you are.
Where did I say gradients? Anywhere in anything that I've posted or
That's
spoken
what
to.
you're trying to use when you say refraction.
Where have I tried to use it then? Show me where I've posted anything that talks about pressure gradients or roll back to this audio where I've mentioned that.
Listen, buddy, I don't know where you came from, but listen, usually when people are speaking to each other, they they get some kind of common ground. So I don't know what you're doing here. You're making stuff. When you say refraction, you get the whole package. You don't get to discount.
It doesn't matter what version he thinks he has for refraction. He can use, because we've had people come in and try this before, and we know what he's going to do. He's not going to make a prediction with it. He's going to make an observation and then apply whatever mathematics he needs to explain it. Being on a
using refraction as an excuse.
And so I hope you're taking notes, Ray. So take notes about it not being a static place where you can claim refraction. So everything is moving in all directions, the gases are. And there's wind, there's crosswinds, there's different direction winds at the same time. There's winds that dip down to the surface from up above and then go back up. And then the other part is, which you're going to have to get to next, which no one even brings up this topic, that the light you're saying is coming from these oil rigs is supposed to be 67 feet below a geometric horizon of the bulge of this Earth curve, but there they are.
Any evidence for that curve that we didn't see?
Yeah, so the point I was trying to bring up, and I just faded, but the light is supposedly coming from a surface that's pointing away from the observer and below the line of sight. So does your refraction account for lifting the object up from a surface that is facing away from us, the observer, and 70 feet below the line of sight? Does your refraction account for that?
It's not my refraction.
Yes, it is.
Law.
Snell's law. Back to Snell's law.
It's not Snell's law. Snell's law requires two isotopic medium, two different ones: glass to water, water to air, water to glass, air to glass. Those things.
Right. So in order to give flat Earth the biggest margin of being true possible.
Oh, yeah, you're not giving us anything, man. Stop saying you're giving flat Earth the benefit of the doubt. Stop it. Stop.
My refraction. You can't really give flat Earth the benefit of the doubt when you don't understand it. So you don't even understand the globe defenses yet. Why would you be arguing for our sake? So just drop that nonsense already.
Asking me questions and not let me answer them.
Just drop that nonsense already and give us a practical demonstration.
If you don't like my answers, don't ask the question. If you don't like my answers, stop asking questions.
I asked you a question. Don't talk over me while I'm asking the question. Give us a practical example of your downward refraction.
You ever stuck a pencil in a glass of water?
Two mediums.
Yeah, that's called Snell's law, Numpty. That's not downward refraction.
Non sequitur.
It's two mediums. Where are the two mediums in the Black Swan picture we showed you?
Yeah, let Dre take this.
Snell's law is irrelevant.
Just easier to listen to if one person at a time. Dre, you feel like you're ready. I mean,
show me the application of Snell's law in an inhomogeneous anisotropic medium, please. I know you can.
In the example that I was trying to present, which I haven't been able to present, I was trying to give flat Earth the widest margin of being real as possible.
No, stop trying to imagine how flat Earth would be with your faulty, small-minded understanding. That's not going to help you. Try to focus on the things that you are claiming, like you think Snell's law causes light to bend in an anisotropic, inhomogeneous medium. That's retarded. You don't know anything about Snell's law, apparently.
Well, I used it in my calculations. I just haven't been able to
Yeah,
get
you're
there
using it
because
in your calculation, but it doesn't apply to the situation you're using it in. So you don't know what you're doing. You're
fair.
like a baby with a knife. You like, if somebody lets you control something with your flawed little understanding, you could hurt someone.
You can say that if you actually listen to what I was trying to do, but I'm not able to present it. So you can't say that I'm not working.
I can
it right.
say that because you try to use Snell's law for an inhomogeneous anisotropic medium. Try to do that in real life.
Well, if you scroll up, I posted how that works with Sidor's equation, but I don't know if you missed that. Maybe you came in late.
Yeah, you can make an equation that doesn't prove it in a practical reality.
Didn't say it does. I'm just working with what we know.
No, you're working with pseudoscience and nonsense that has no basis in reality. That's the issue here.
Well,
Of course, they're gonna create a equation and all sorts of excuses for why the stuff doesn't work in reality. That's not our problem. That's your problem.
Well,
You have all complete lack of evidence for your claims. We
That's not
live in
true.
reality. We understand how Snell's law works. We can apply it. We see that light does not bend in anisotropic inhomogeneous mediums. When we use salt
we do.
solutions, for
We
instance,
see that all
and
the
we
time.
shoot lasers through them,
Of course
they
we
appear
see
to
that.
bend. Then globers say, "Oh, that's light going through the air. That's how it works." But when we stir it up, like the medium is actually in reality, it doesn't bend. So you're retarded.
Okay. We do see light bend through anisotropic mediums. Like that's very well recorded. There's photos of it.
Inhomogeneous as well. No.
Let's just go find a picture of it so you can actually just see it rather than try to describe it with words. I mean, to me, it just feels like you guys are afraid of what you're about to learn, so you just don't want me to finish with my explanation.
What is it that you think
That's hilarious. We're so afraid that we make 24-hour videos here on YouTube every day.
There's nothing you can present that we haven't already gone over 1,000 times. You're just so behind the curve that you don't know what you're talking about. That's the issue here.
It's fucking ridiculous.
You're like late to the show. You're like late to the show, man. You're like 5 years late to the show.
I seem to recall like educating Ray Notes on his globe every step of the way, every time he tries to make an argument. I would really like to know what it is he thinks he has to teach us.
Maybe I'm teaching you nothing.
I'm pretty sure Drace just taught him what the difference between freaking now I can't freaking know. I'm just that ridiculous. Never
Let me
mind.
teach you another thing.
The refraction
if light
index,
is hitting normal to the surface,
Rayleigh
is it refracting?
criterion.
Delio, Trace is going.
If light is hitting normal to the surface, does it refract?
Depends on the change in the mediums.
No, it doesn't. If it hits normal to the surface, it doesn't refract. Again, you don't know Snell's law.
Yeah, maybe I don't. But I haven't been able to talk about what I was going to show, so.
So you're going to talk about something you don't understand and try to make an argument based off of it. Good job.
Well, I mean, you guys could let me finish what I was going to say and then show me where I'm wrong.
Give us a little nutshell. Give us a little snapshot then.
Well, didn't we already tell him where he was wrong before he even finished when he admitted he was just begging the question?
Yeah, he is still, but just for the sake of argument, go ahead. What's your premise now?
I'm a little bit frustrated because I was trying to find this where we can watch light bend through an anisotropic medium, but I'll try to find that later, I guess.
Yeah, but is that atmosphere? Hold on a minute. We have to compare it to the atmosphere, though, right? Ultimately, to compare it to the horizon.
Yeah. No, that's
Okay.
Helio. Yeah, that's right. We'd have to compare it. would have to be similar, right?
Doesn't compare.
Because that was the original argument.
Yeah, my argument is that
you're not going to shoot a laser through a fish tank and watch it bend through water and then say no.
Yeah, but maybe I guess that's a good point that you bring up, because one of the things that I thought might be kind of interesting is that if you did shoot a laser at the point where BMLS B69 took those videos, and you shot those laser out at the platforms that are really at a great distance,
I bet you any money. If you were on those, old platforms, you'd be able to see that laser from that beach. I bet you any money.
Yeah, finish please.
That's not where I'm going with it. So if you did that, and then you had a second observer at a great distance away that could see the entire expanse from a perpendicular angle, and if the laser was bright enough, it would light up the air on its way to the journey, and what you would end up seeing is a curved laser that runs along the top of the water and hits the platform. That's what.
Oh, you mean looking from the side?
Stop.
From the side, yeah.
That's hilarious.
Yeah,
So you're saying the
yeah.
horizon curves. If you look at something from this laser from the side, and the laser will curve along this curved horizon that you're now imagining in your head. This is nonsense. In reality,
no, it could be.
the horizon
Yeah,
is
it's just
still flat,
speculated.
even if you look at the laser from a different angle. That doesn't change, and the laser still looks flat. That's how it looks like in reality. And by the way, I'm going to teach you another thing about refraction. Different wavelengths of light refract at different rates.
Yeah, that's why I picked a very specific one in this
So when
example.
we have lasers of different wavelengths, and we shoot them for over 10 miles, and they're only, let's say 6 feet off the ground, they're not supposed to both hit the target 6 feet off the ground 10 miles away.
Right.
That's supposed to be impossible on your globe, even with refraction.
True.
Do you understand that?
Yeah, that's what you're saying. I think that other people have mentioned that before, but I haven't seen that demonstration yet, so I don't know.
Okay. Let me help you even more. Okay. Visible light refracts more than infrared, which means if your delusion is correct, and visible light is always refracting around the globe to hide the globe, and so when we look at the world record long distance photographs and we see them taken in visible light and then 4 minutes later in infrared, the infrared should have the horizon be much closer to the geometric horizon because it refracts almost nothing, very little. However, in reality, the world record photo is the infrared photo. So you're just dead. You don't know what you're talking about.
Well, I haven't seen any of what you're just talking about, so
Yeah, well, can we just get the main part is that everything that you've talked about so far is not talking about reality, or it's talking about a part of reality, but it's not talking about what we're talking about. Is looking out over the ocean and seeing long distance landmarks that should not be there. You're talking about something else in a laboratory.
Well, let me say this really quick, and I'm going to jump off. His base premise when I started listening was that he said, "Well, I can throw a bunch. I can use the math to make it look like what we all see, even though it's a globe." That was basically what I caught from his premise. It's like, even though it looks flat, I can throw a bunch of numbers, and we have math, and he started posting some stuff with different math numbers in there and stuff. And so this is why it looks flat. And this is what all the globers do, right? I mean, it's just it looks flat. It looks flat because it looks flat. Go ahead.
He's also admitting that he hasn't looked into the real life examples like Drace was presenting. He's only looked at the math on paper and saying this math works on the globe, but he hasn't looked at the real life examples like the laser test and all that kind of stuff. So he admitted that he's ignorant about it, and that's his excuse, that he doesn't know about it.
Right, but that's okay. That's okay. I mean, but he's also said from some of the talks, I think he's holding back. I think he's just kind of trolling a little bit because he's just from the talk, I can tell that he's familiar with our talks and stuff and some of the tests. and so he's just kind of holding back a little bit. So I'm kind of in between whether he's acting ignorant or he's just an actor here, or he's actually just learning. This now.
The things that
Isn't it
Drace mentioned, I honestly, I haven't seen those myself. I'm being honest. And Helio, your description of my angle of attack on this problem is accurate. Yeah, I'm using the math. Didn't go out and do field studies myself. That's all very fair. And you are well within your rights to throw
all right, so you're
going. I say.
All right, so you're going with the math first and observation second.
Well, I'm trying to answer this question as why. Well, the question I was specifically trying to answer with my analysis is why would anyone be able to see across a lake that's 10 miles wide? Why would you be able to do that given the geometrical assumption of the Earth having, in the case of the math that I did, a radius of 3,950 miles?
Right, and that's the basic question. So
Right.
You're asking the right question.
So when I looked into it and began to research, because this area of refraction in this topic is the one that I despise the most, due both to its nebulous nature and
Because it's
the amount
so
of
vague.
math.
It's so vague,
It's
right?
math. It's math. It's math.
But
I fucking hate
you're
math.
saying
I don't
this,
like it.
You're saying this area of refraction, but you can't even name the refraction that you're talking
Yeah,
about.
you don't even know it.
I
Yeah,
didn't
exactly.
get there, but I wasn't.
No, but you already did. You already did get there. That we heard what you said about it.
Well,
I mean, you've been
heard what I
talking
said
to us
about it.
for 45 minutes, man. I heard what you said about it before I even jumped in.
Yeah, but
That's why I jumped in.
I literally I got to the point where I wasn't even at the halfway point of my explanation, and I've been stopped since.
We don't need explanations. We need demonstrations, Ray. That's the thing that you guys don't seem to understand. You don't seem to be able to tell the difference between claim and evidence. It's the evidence part we want. We know your claim.
No, I get that part, but the question that you asked me was why should we be able to see further than we do?
Yeah, because there's no obstruction, obviously, or else you would see it blocking something.
Right. I get that part of it.
So why do we think there's an obstruction that we don't see obstructing anything again?
Well, my answer would be refraction.
Okay, so what are you basing that on? There must be some sort of a measurement of the obstruction in the first place in order to get to that.
Oh yeah, so we're gonna say if we don't.
So who measured the obstruction that we're not seeing that you say is refracted? How'd they do that? Why do we think this?
It was Jimmy. He was the one that did it. He was the one that did the measurement.
It always devolves into a joke because that's what it is.
No, maybe it is. Maybe it is. But if you're asking me, that's the joke I'm using because that's the one
it's funny how it's telling that you had to come with a joke instead of the measurement I asked for. It's like that measurement doesn't exist. And that you're just making excuses for the geometric horizon that isn't there.
No, you asked me for the measurement and I gave it to you. It's a radius of 3,900.
No. That's the claim. See, once again, you guys are mixing up the evidence and the claim. That was the claim. I was asking for the evidence. That would be the measurement. The number isn't the measurement. We're asking how that number was derived from what measurement.
Yeah, you're correct. That's fair. That is a solid criticism. What is the measurement? I don't have an anser for that. So
I'm surprised you don't know the difference. That's probably why you're confused about this stuff.
I just missed it.
Excuse me, and I made all my sentence. So you're taking as face value all the math that was given about the globe and saying, yeah, refraction, paka, and then the real life examples that are presented and the evidence of the curvature, that the measurement that you've been asked for, you say no, it's not there, it's a joke. And then the real life example you're ignoring, which is, it's interesting that your approach is such.
Well, I did use real measurements up above. They're way up in the chat when I used the geometrical formations of known distances between cities, which I don't think anyone disputes. It was disputed in that particular conversation. But those are we know the exact distance, or I'm sorry, approximate distance between.
Estimate.
Yeah, it's an estimate. Well, it's approximate. I don't know if you'd call it an estimate. Technically, it's an approximation, not an estimation. Those are two different things. But Barcelona to Hanoi, Hanoi to Nairobi, and then that creates a triangle within which you can place Riyadh, Saudi Arabia, the distance between.
Come on, we're not doing this again. This is stupid.
I'm just saying, well, because those are measurements, right? people do measure we travel.
They're not measurements.
So you're saying those distances are false?
No, you just said they're an approximation.
No, I said they're an approximation, not an estimation. They're not estimates. They're approximations.
Yeah, that's what I said. You said it's an approximation, which means approximate, which means not measured. Yeah?
No, that it means that because of the way, I mean, there's so many different ways to travel between those two cities, right?
No shit, man.
Okay,
so
then tell us how it was measured. Just tell us that then.
How cartographers do their job? I'm not a cartographer. How would I know that?
You just had a disagreement about if it was measured or not, and then you just whistled through the graveyard past it. But go ahead, no problem. Don't mind me. Just pointing out bullshit as it occurs.
Yeah, I agree, Sonny.
Well,
so we ask you for a measurement of something that would be curve. You come with a measurement of something else that would be distance that you don't even know how it was done.
I'm not a.
Well, what good does that do?
Next. Well, it shows that measurements do occur, right?
No, well, those are just numbers on a screen. As far as you can't elaborate on the method, you can't tell us what was actually done. So far as we're concerned here, those are just numbers on a screen, and they're not even the numbers for the thing that we were asking about. So we can just discard that.
Yeah, I'm just not sure how rational the discussion is if we don't agree the distances between cities.
Whose distances are they? Like
everybody's. They're traveled every day.
Travel how?
What does it have to do with the topic?
Plane, train, and boat.
Yeah, we're measuring the 8 inches per mile squared. You know, like the curvature of the geometry of the ball. Like, okay, where is that curvature? Where is that curvature between the two cities that you're talking about?
Well, it has to be there because.
Okay, it has to be there. It has to be there. Okay, so then it must be there. Then, if it has to be, right?
What's the point in asking a question if I can't answer it?
Well, okay, you said it has to be there, so therefore it must be there. So why don't you just measure that then, since it's there?
Okay, wait. We also see with the long distance photographs that the Earth is not a ball, and so there's no way that it could be a ball. So why would it must be a ball?
Yeah,
why do you say that?
There's no evidence for the ball.
Well, I just provided like the distances between those cities create a
tetrahedron. Is that telling you what their geometric relationship and angle is to each other?
That's what a tetrahedron is. Yes, there are angles in relationship to each other.
No, but that tetrahedron is drawn on a sphere. You're not on your little sphere that you're drawing this on, and you're not measuring this in reality.
Yeah, but even if I give you that it was,
you're just imagining things because you're a little bit retarded. It's okay. It happened to everyone. We all got indoctrinated with the globe.
Well, if I can't answer the comment, then sure, I'm retarded.
It's weird that you go to something derivative, though. Like, you show us something that isn't the thing that we were asking for, which is Earth curve, and then you say, well, if this is like this, then Earth curve must be there. Okay, so why didn't you just show us the Earth curve then that must be there?
Because you asked me for something that was measured, so I gave you a measurement between the
something specific. That would be the Earth curve, and then you go and give us a measurement of something else.
Well, you said that I was working in math with no measurements, and I said I already dealt with measurements.
No measurements of the thing in question.
The curvature of the Earth. Yeah,
yes.
I guess that the Earth is flat. Because I don't have that at my fingertips. I haven't researched that yet. Do you want me to? Do you want me to bring that next time?
Well, that should be your whole purpose here if you're in this server as a glober.
Yeah, maybe go back to first grade. Go back to first grade, and when they talk about water level, the top surface of water, maybe you need to review that part.
Yeah, you don't need to go back and try to imagine some flat Earth model. You just need to go out and test if your assumptions are correct, not just base everything on those assumptions. Get some lasers of different wavelengths, see if they hit the target. If they do hit the target, you don't have a globe.
You don't want to do it. It's been done already. There's many laser examples I will show you. There is no curvature between point A to point B to point C to point D. No curvature between any points.
Yeah, and laser targeting by the world's militaries at 100 miles and even further, which is classified, blows it out of the water completely.
I haven't seen any of that. I'd
Oh,
like
really?
to, though. No, I haven't.
Just go look it up. They're not shy about telling you. Like, they'll tell you right up to the confidentiality limit.
Yeah, don't do it for us. Just do it for yourself. If you're gonna believe so hard, zealously even, in the globe, then maybe you might want to find some substance there.
I guess I didn't imagine people would dispute the distances between cities.
No,
Who's doing
no,
that? You? No, that's like a silly straw man and some, I
Yeah,
don't
you're
know, BS.
strawmanning us because that's not what any of us are doing here, and that's not what we did. You just brought up another non sequitur, red herring, that doesn't fit the conversation, and you keep doing it.
Triggered. He's just triggered because he knows deep down in his soul that I'm right, but his ego doesn't want to let go.
He's just saying, oh, you guys don't believe between the distances between cities. Oh my God, I can't believe I'm here talking to you guys.
Yeah, like, look, he's got a stack of papers. He's been doing a little bit of reading. He's been doing some homework. So he's got this knowledge he thinks he has. And so if he just throws that away, maybe he thinks he's just going to become invisible or something.
So now is it not flat Earth, it's mind reading, or still flat Earth?
This is the flattering your imagination, right? You have like a flat disc in your mind, and you're like, it can't be that.
Another red herring. He claims that we're doing mind reading when you just opened up your mind and told us what was in it. That's not anybody making shit up. You're making shit up about people making shit up.
Yeah, you just said it. We repeat it. You're BS strawman, and you're saying, are you guys mind readers? No, you just said it.
Oh, you were saying why I think what I do, why I do this, why I do that. There's like a lot of
No, we're
assumptions
just
in there.
analyzing your logical fallacies. Like, for instance, you post this picture of a globe that you're trying to prove. The
Wouldn't matter.
conclusion that you're trying to get to is the Earth is curved. But that's the premise of your nonsense drawing.
Yeah, but even if you flatten that motherfucker out, that apex is still going to be orders of magnitude higher. It doesn't make any difference. Even if you flatten that out, it doesn't come out. The math does not work out to flat.
Well, guess what? There's no apex. Maybe that's the reason.
No, there is an apex. Yeah, the apex is...
Your height above water?
No, the distance between those cities creates an apex that's 200,000 meters above the three outlying cities. So even if you flatten that out,
where was that measured?
It's Euclidean geometry. It's
So where was it? I didn't ask you what type of geometry. Why? Stop talking. Listen, I didn't ask you what type of geometry. I asked you when was it actually measured, because you're making claims now of actual geographic and geometric positions. So where's your validation? Where's the measurement for those?
Well, are you asking me when or where? There was two different questions in there. When were these measured?
When and where was that measured?
Well, the where would be Riyadh, Barcelona, Hanoi, and Nairobi. That'd be the where.
Yeah, the distance between the points is not in question. Do you not understand that?
Well, that seems what Sonny was asking me.
The distance is still the same, regardless of the globe distortion.
And stop putting words in people's mouths. I don't appreciate it. Listen.
You used where and when, not me.
You got to keep track. You got to keep track, buddy. You're losing track here. You are claiming that these distances are forming an apex. That's the measurement I'm talking about. Not from point A to point B. Because we all know we work on a a rectangular coordinate system when we're traveling on land, and actually on the ocean too. Those charts, those flat charts.
Yeah, it doesn't, even if it's flat, even if that's flat, I can put it in Photoshop and make it flat if you want. Oh,
Yeah,
here,
but you
actually,
can't
I did the
measure-
flat
yeah,
version.
but-
Let me
yeah,
grab
but-
it for you real quick. I
Yeah,
did the
but
flat
I
Earth
don't-
version.
I don't care. It's another red herring. But you can claim that people are sailing along on curved waters, but they're actually navigating using the tools and the mathematics and geometry of a right triangle and flat horizontal surfaces. The x-axis, that's the one you're traveling on. You don't see a problem there if you're claiming it to be curved and we're navigating with it flat.
I
How
do see
you
a
would be
problem
out
there.
of location. I was almost
that's-
done. So how you would be out of location? Are you aware of that?
Yeah, that's a question of precision, what you just mentioned, and that would be a problem. So that would make these approximations. And yeah, so that is a fair observation, and you are correct that these are imprecise observations due to the fact that they're all approximations and they can be slightly wrong. But the reason
What are approximations though? When you say what are you claiming to be the approximation?
the locations of the angles of A, B, and C. So I just posted it in a live chat. The basic idea of what's going on here.
Okay, you're talking about cities, and you're also talking about angles. So,
Yeah.
are you talking
what-
about elevation angles?
No, although I did factor that in eventually. But
Are you talking about elevation?
No, I'm talking about vectors. So these are directions along a line.
So, like for instance, let's say you're in North America, where I am at, and then you go over to somewhere like Southeast Asia, and that would be pointing away from me at like a 90-degree angle. And then you get to Australia, and Timbo down there is upside down. Those are the angles you're talking about, right?
Yeah, you can. Those are 3 points. Yeah, we know those exact locations.
Okay, good.
longitude,
So how did they measure those?
I don't know. It could be really wrong, right?
I rest my case.
So then we are disputing the distances because we did say we weren't.
No, we're not.
Who gives a fuck, dude?
Differences. Fuck.
This guy's plain dumb.
This guy's
Yeah,
brick.
you're-
More plain dumb, yeah.
Ridiculous. I already claimed to you that we're not disputing the distance. I'm disputing the angular displacement. You're saying there's an apex. That's what I'm disputing.
Also disputing your inferences from those distances, your conclusions of curvature from them. Disputing that because every time I ask you to directly show that, we get this instead, which is a runaround.
The whole argument is circular to begin with. Like, he's saying if you draw a triangle on a globe, then you end up with proof of a globe.
No,
it's
you
just
don't.
retarded.
No, that's not what I'm saying. That's wrong. It's straw man.
Yeah.
Oh, it is. So this doesn't prove the globe at all, or Earth curve, and so it's just nonsense.
Well, this particular proof proves that it cannot be flat no matter what. It just can't be flat.
No, it just means that your map that you're basing it on isn't correct. That's all it does.
The math is way too simple. Those vertices are way too simple to calculate. It's really simple to calculate those vertices.
Yeah, but you haven't told us how they measured them in the first place.
We're waiting for your verification.
For them to even exist in the first place, they would have had to have been measured by some method.
He doesn't know.
All right,
He already knows it. He doesn't even know how he got those numbers.
Yeah, it would also require the verification of the thing in real life, how the angles are actually in real life, which he never does.
Oh, yeah. Okay, fair enough. So this is the part that I keep missing that you guys keep beating me over the head with, and I really want to close the circle on this one. So I guess this is the way I look at it, and then throw darts at this, why this could be wrong. So I have these angles. You can see it with angles A, B, and C, and they're connected by vertices of a definite length. I guess what I'm saying is that We know the angles for sure because there is not any other way to create a triangle of that shape in the absence of those particular distances. And if they're different, if the angles are different, that means the distances must be different.
You don't have that triangle in real life, though. That's the problem. You just have a drawing on a globe, and you say, "Oh, there's a drawing on a globe," and I draw a drawing on this weird flat Earth map, and that means because the weird flat Earth map is not like the globe you drew on, it's not the same. Check it in real life.
Yeah. So congratulations, congratulations, you're begging the question once again.
He's comparing cartoons and saying, I think this cartoon is better than this one.
All I'm doing is taking the distances between three cities. That creates a triangle. At 3 points.
Yeah. That's obviously the problem here because you're using
All right, I'm missing the problem.
AE projection, azimuthal projection, for your flat Earth map.
No, I didn't.
That's what you're using. That's the problem. It's not accurate distance wise when it in that configurations unless you're going towards the north.
Yeah, and stop saying no, Ray Notes, because it's exactly what you did. You posted the AE map, so stop saying no. You do this a lot every time you're called out on a claim that you made that's bogus, and you go, no, I didn't say that, when you actually did. Quit doing that. It's annoying.
There's the distances between the three cities.
I just heard him say distance between three cities creates a triangle, right? Now, definition of a triangle, it's three straight lines, right?
Sure.
Straight lines. One point to another, three straight lines. Not curved lines, three straight lines.
Mm-hmm.
He got that part. The triangle part. None of the lines are curving like you're claiming. That would be crazy if someone claims that the triangle has a curve adjacent, right?
Correct. I didn't. These are not curved lines.
I don't know how that makes. I don't know how that makes a point at all about anything, whether it's flat or globe. It really doesn't make any sense when you're talking about three cities.
He's saying in real life there's a distance between these cities, right? And then he goes to the globe. Look, this city in the globe, this city in the other globe, in the other side of the globe, and this other city. We can make a triangle on the globe. Therefore, it's a globe.
Not a triangle. You're missing the fourth point. There's another point that gets added into this measurement. So even if this is flat, right? So let's say this is flat as pancake, because that's what you guys believe. I guess I don't know. So
that's what you believe.
Well, I'm not.
Yeah,
sure
that's what
exactly.
you think we believe, right?
That's what you have in your imagination, bro.
Yeah, but it's yes, there's an approximate distance. And none of us here would disagree with that. An approximate distance from, as the crow flies, as they say, right? From one city to another, or an airplane flies. Hey, what's really cool is that airplanes do fly from one city to another, and guess what? Their flight path is pretty accurate as far as how many miles they go from one city to another in a straight path.
Mm-hmm.
Okay, so what's your fucking point?
I'm saying if you add a fourth city in the middle of those three straight lines, the distances between the other three cities raises an apex, a tetrahedron apex that makes it impossible for it to be flat.
No, you imagine there's an apex there because you're drawing it on your globe.
The apex doesn't emerge as a proper. It is not an emergent property of the globe. It's an emergent property of the distances themselves. Doesn't matter if they're flat or not. It's not even close. It's orders of magnitude higher.
Maybe the fourth city is up in a high mountain, and he's saying, "Look, it's there's a difference of altitudes." Therefore,
no, he's saying somewhere in the middle of the triangle, there's another airplane that flies.
No,
somewhere there.
Another city.
Riyadh. Yeah, Riyadh, Saudi Arabia is right in the middle. And if we look at their altitudes, this is the relative altitude of each of the elevation, of each.
So the altitudes are different.
Dude,
that's hilarious.
That is crazy. You're the worst troll. I'm not the worst troll. It's just
bro. Listen, Helio. The cities are at different altitudes. Therefore, It's a globe.
Oh, the
I
altitude.
know.
Was
It's not
he
like
talking
so
about
hilarious.
altitude?
No,
It's so
not
hilarious
altitude.
because altitude is
It's
taken
the
from sea
apex.
level, and it's taken with
Apex.
angle measurements, which you cannot do on your globe.
Oh, he's claiming he's not
apex.
claiming altitude, but then he's posting this shit in here, claiming altitude.
If you
The
create,
apex.
it's
What
way
is
higher than all the other cities.
Those are just altitudes. Those are relative to sea
They're not
level.
altitude. No, they're
Yeah, they are. I just checked
hold on.
it. Those are the altitudes. That's the
You
elevation.
posted that
above
shit
sea level.
earlier, but nobody flies that necessarily that way. I mean, Riyadh to Barcelona,
Ray,
sure, they probably
do you
fly from
think
there to
do you
there,
think
Hanoi,
altitude is
Barcelona.
do you think altitude is a consequence of the globe?
Wouldn't even matter. It could be flat in this example.
Buddy,
Doesn't matter.
idiot.
Yeah.
Buddy, idiot. We don't deny topography. You numpty fucking numbskull.
I said this like 2 hours in chat.
Yeah, he's saying, oh, there's topography, and you have to go a little higher to this city, and then a little lower to that one, and then a little higher to the other one.
In the
You see,
middle,
it's not, it's a globe because there's topography, guys.
Though Riyadh resides at that height
Never seen.
relative to the other cities.
Ray, are you one of them dipshits that just found out that
Never
there's
seen,
an
bro.
argument about the shape or the nature of the earth? You
Sorry.
just fucking went on Google and it was a bunch of liars, then you just find Facebook.
Whoever is speaking, you gotta fix your mic, sir. We would like to hear what you're trying to say, but you're gonna have to figure it out, whatever issues you got with your mic. Go ahead.
This is
Oh my
hilarious.
God! It's Sleepy Joe.
So Ray, how do you get elevation angles on a globe?
I don't know.
Well,
It
you
doesn't
can't.
matter for
You
this
have
example.
a curved baseline. You don't have a flat baseline, so you don't have a triangle, so you don't get elevation angles.
Yeah, in this particular case, the vertices are not curved; they're flat.
Oh,
The apex is so
we
high.
do have elevation angles for altitude, buddy, because they are measured off of a flat Earth.
Yeah,
The
if you
baseline
measure,
is sea level, not sea
Mhm.
curve,
right?
and we tested the sea level with lasers of different wavelengths and cameras of using different wavelengths. So we
Right.
know that sea is not curving as your globe, as you imagine on your globe, and so no matter how many crayons you bring out and how triangles you draw on globes, it doesn't change the fact that in reality there is no globe.
Yeah, so even in the complete absence of any curve whatsoever, if we take the distances between those four cities, it puts Riyadh at basically 203,000 feet above the other three
No.
cities. You can't escape it. It's just simple math. It's Euclidean geometry.
Its elevation is already its elevation is 600 meters from sea level, Riyadh.
Yeah, that's its physical elevation above sea level.
Yeah, that's its elevation above sea level. For instance, Nairobi is 1,795 meters above sea level.
hmm
Yeah,
I'm
that's
not
a
disputing
problem.
any of that.
That means there's topography. That does not mean anything about globe.
But if we measure the distances between those four cities, it creates a tetrahedron, with Riyadh being the apex at 203,000 feet above the other cities.
On your imagined globe, show us that
On
evidence
map.
of that happening in reality. You can't just claim endlessly that it's happening when you have no evidence of that. You just have
All
a
I did-
drawing on your globe.
Sorry, all I did was just measure the distances between those four cities. That's
You
it.
didn't measure the distances. You admitted that already. You just took the known distances and then assumed that it was drawn on a globe, and therefore the city that's not as high as the other cities is much higher than the other cities. That's retarded.
Yeah, but even if I was wrong,
Yeah, but you are wrong. Don't say nonsense like that anymore.
okay, given that I'm wrong by 500 miles on any one of those cities or all of them, The orders of magnitude of that apex are so great, you still can't get a flat Earth out of it. It's
You're
done.
imagining
it's over.
the apex,
Flat
buddy.
Earth is done.
It comes from your imagination of the globe. It is not in reality. You have no evidence of it being in reality. Get that through
Just
your
the-
thick skull.
Just the evidence of the distances between those cities.
Yeah, that's not evidence of your imagined apex.
Yeah, it
This
actually
guy,
is.
flat Earth is done because he did a maths equation. Are you a fucking idiot, mate?
You can't flatten out those distances. It's not possible.
You're an idiot, mate. You just said flat Earth is done because
It's
you
done.
did a maths equation with a tetrahedron.
That's right. Can't
It might be a language barrier.
If you
You
can
got
make
mic
that,
check?
if you can make that, oh, that's
Yeah,
way
that's better.
It's
You sound
way
good,
better.
obvious.
Cheers.
Yeah, way better.
Yeah, it's circular reasoning. You understand that,
No,
right?
it's not. It's
Yeah, it
it's
is.
definitely not. No,
Yeah, you
that's wrong.
You started with the globe to try to end up with a globe.
That's stupid.
That's all you did.
That's dumb. That's dumb.
Ray,
Yeah,
this
yeah,
this
yeah,
apex
it is
is
dumb. Please stop.
It's just dumb.
yeah, this apex you keep incessantly referring to is a consequence of curvature, right?
Nope.
How not?
Nope, not a consequence of curvature. Not the way this math works out. It's just the consequence of the tetrahedron that would be formed by those distances. It could be
And the curvature, you idiot.
no, not
So
the curvature.
in geometric terms, in your
Geometric. yes.
paradigm, why would one city
Not my
be
paradigm.
elevated above the others?
I can't answer the question. It's just that that's what the distances dictate they must be.
You can't answer the fucking question. You are an idiot, like Timbo said, because it'd be a consequence of the curvature.
No, it's not a consequence of the. Well, I guess.
Well, I just
technically,
asked
yeah,
you in,
you're right.
in geometric
that's
terms,
supposed-
and you
All right,
described
yeah,
us
no,
why
no,
this city would be elevated above the others.
Yeah, all I'm saying is that the
So the
distances
concept-
dictate that's
so-
where
so-
the
so the
apex. Sorry, I'm
curvature is the
speaking. Sorry, I'm
consequence,
talking.
and
Sorry, I'm
no,
answering the
I
question.
don't give a
Sorry, I'm
shit.
answering.
So the
No, that's
consequence
fine. I'm
is
answering the question.
curvature,
No, it's not.
and then you end up with the claim that the proof is of curvature. That's the circular reasoning.
No, it's not the circular reasoning. I'm
Yes,
saying that
yes,
you-
it is. Read the definition of it.
All right, let's start from the beginning. All I'm saying is this: if this is the, I'll make only this one claim. This is very, very simple. Taking these distances between these cities, those four cities, it's impossible to create a flat shape. Impossible. That's it. It's the only claim I'm making. It makes a tetrahedron with an apex where Riyadh, the city of Riyadh, Saudi Arabia, resides at 203,000 feet roughly above all the other cities.
No,
With
it
those
doesn't.
distances.
No, it
It
doesn't
does, it's
because its
math.
height is actually measured in real life with angular measurements, and we know how high it is from sea level. Your imaginations don't change that.
I'm not imagining the distances.
No, you're imagining your triangle on your little drawing. It doesn't reflect reality and has no relation to it.
Well, those distances aren't real.
You've started with the premise that the Earth is a globe. You've solved for it being a globe. Therefore, it's a
Your
globe.
imagined altitude isn't real.
Even if I'm wrong about everything that you guys just said, that doesn't
Well, you are.
evaporate. Okay. let's
You're
say I'm wrong.
embarrassingly wrong, but you don't realize it.
Okay, so I'm embarrassingly wrong. Even if I'm wrong about everything that I think, the immutable properties of those distances between those cities creates a tetrahedron with Riyadh being 200.
No, I asked you about the immutable properties of this demonstration here on paper, and you couldn't even tell me them.
Well, just make the shape flat somehow, I guess. I don't know.
The immutable property would be that the Earth is curving. That's why one city is elevated above the rest. So we should be able to go out into reality and measure for this curvature, which we've done, and it's not there. But you
Either
just
way.
hand wave dismiss that, of course.
He's saying that since this middle city is above the other ones in altitude, this is not a chessboard. It's not a flat table. That's what he's saying. It's not It's not a completely smooth flat table because this other city is higher than the other ones. It's not a flat surface. That's what he's saying.
He's not even fully
That's
saying
what you're
that
saying.
because he's admitting that it's at a lower altitude. He just imagines it at a higher altitude because of the distances he's calculated from somewhere. God knows how accurate all of the distances is. There's a bunch of small discrepancies in shipping lanes, in flight times. Like we can't be 100% sure of that, all of those distances. I'm not saying we dispute the rough distances. Like you said, they're approximations. So you trying to use them as a proof of the globe is pretty retarded, since you're getting those mostly from a globe projection. You're not testing any of this in reality to seeing if any of it actually confirms to what you're getting in your calculations or your drawings.
But even if we grant everything that you just said is true, one thing that we can't escape from is the fact that these cities do reside in distances from each other that creates a tetrahedron. It's a 3D shape. It's just not possible to create. You would have to change the distances to flatten that out.
Topography.
You're imagining a 3D shape in your head, and you're drawing it on a piece of paper. In reality, we measured the ground. The ground isn't curving, so no matter how much you imagine in your head that the Earth is a ball, it doesn't change the measurements of the ground itself. Do you understand that?
Yes, I do understand that. And even if you create nothing but a flat plane that these cities reside on, then you're left trying to explain how their distances create the shape it does. And it's not from my imagination, it's the math.
No, we're not left trying to explain anything, because we are not a religious belief system like the one you come from.
There's no religion in my proof.
Yes, it is a religious belief system.
Posted right there. Just look at it.
There's no actual evidence for it. You just have to take it on faith. Just like you're telling us to do right now, because you're imagining circular reasoning, and we just have to take it on faith like you did. That's
Don't
not
take it on
logical, my
faith.
friend, and I that's not good enough for me. You got to show me evidence in reality of your nonsense.
Well, I'm showing you math, and you don't like the math. So
No,
throwing-
you're showing me math of your imaginations and some distances that you think might not work on your imagined flat Earth. I don't know the complete layout of the land. I have not surveyed the land myself and have an accurate flat Earth map. What you're using, is a projection of the globe. You're retarded.
Even if you remove the projection of a globe and just use the Euclidean geometry from the distances, it still creates a 3D shape. It does. It's inescapable.
We don't know how accurate all those distances is. We haven't looked into those specific distances. You haven't done that research. You don't know if there's any discrepancies in any of that. You're just imagining it based off numbers you found online.
Yeah, but due to the degree of
But
magnitude.
that's exactly what you're doing, and that's not valid.
Yeah, but
Wait,
due to the degree,
hold on, isn't Euclidean geometry straight lines?
That's what I used, yes.
Okay, so how many straight lines make a globe? Now we've heard a lot. We've talked to a lot of globers. They talk about non-Euclidean geometry, and yeah, I understand that. But you're saying Euclidean geometry makes a globe?
In this example, it makes a tetrahedron, which isn't flat.
Oh, so it's not a globe, but it isn't flat.
It can't
So
be flat with those
in
distances.
between these cities, you create a tetrahedron, whatever. Therefore, the whole world is not what you have in your imagination. Okay, that makes sense.
Yeah, he was saying there's some point in the middle of the triangle that makes it a globe. That's what he was saying. That's what I heard. Is that what you're saying?
No, I'm not saying some point. I'm saying Riyadh, Saudi Arabia. That's the point. It's a very specific one.
Oh, but that's the only place, or is there? I mean, if you're going to apply,
No, Helio. He's saying that the shape that is being created between the lines that he put between the distances is creating a shape that is not the shape he imagined. You think the world is a flat, whatever imaginary thing. It's not that. It's not creating that thing that he's thinking that you're thinking. Therefore, you're debunking.
I mean, it's just like he posted several times this little graph that he posted, That didn't necessarily make any sense to me, but did you saw what he put? You know, it's it's just like the location, height in meters, Riyadh, Barcelona, Hanoi, Nairobi, and the apex. Is that what you're talking about?
Me, yeah, that's what I'm talking about.
All right, so Riyadh is the what? The
Riyadh's in the middle of the tetrahedron that these vertices would form.
According to what?
Indisputable math and geometry.
Indisputable math and geometry, based on who studied this and where has it been discovered?
I think it's right there in what I just posted. Right, each one of the formulas lays itself out.
You must be a fucking
post this little
fool, Ray.
graph. Post this little graph, and that just shows us everything we need to know about the Earth. Right there, you just showed us. Earth can't be it can't be flat because of this little fucking 6-layer graph. Well, it looks like it's from Excel.
No, these cities are arranged in a geometry that can't be flat. Is what I'm saying. It doesn't tell us everything about.
No,
the world.
you have arranged them in a geometry.
In your mind.
You're not understanding that yet, Ray. When did you go out and confirm what you're trying to say here is reality?
If you think
you
those
didn't,
distances are wrong,
Let's skip
then you
ahead,
pick
and
one.
you didn't. So this is all just a thought experiment in your mind with what you believe the Earth to be and how it's formed, how it's shaped, how the land masses are spread out, what you believe the distances to exactly be. This is how you've drawn your conclusion.
Yeah, I believe these
You
distances
verified
are
it
accurate.
though. We're sitting here
believe they're
humoring
accurate.
you for hours now on this absolute nonsense.
I'll tell you what, man. You're free to believe anything you want to believe, but I'll go ahead and believe my own eyes and what I see across Earth every day. It's a level stationary plane, as far as I know. I've never seen a globe, unless it was on television. But I don't believe those nonsense controllers that try to manipulate our minds. I don't know where you came up with this idea. With these 4 cities creating an apex where it shows that the Earth can't be a level stationary plane with the apex number. I mean, you could sit here all night probably and try to explain your mathematics with us. I don't think we're ever going to agree with you on that. I don't.
It's not mathematics, Helio. It's valid math for a globe. But when did you verify it's a globe, Ray? That's what we're asking you.
No, this math doesn't require a globe. This math could be done on a flat. The 3 outlying cities around the perimeter of the triangle, the tetrahedron, can be on a flat plane, and this math will still lift. It has
Certainly,
to raise
but when did you
up.
go out and actually verify that the city, whichever one it was, is elevated above the others in 3D space?
Oh yeah, so if these distances are wrong, then yeah, that's
No, I didn't ask you about distances. I asked you when you went out and verified what you're claiming here.
I was asking about his chart there. He was talking about height in meters. It said Riyadh 612, Barcelona 12, Hanoi 5.
No, yeah, I had to do that because what I wanted to make sure is that when I created the tetrahedron, that actually did place Riyadh at 203,000 feet above the other cities. I wanted to make sure that that wasn't a feature of the topography. So I went and gathered the elevation above sea level of each one. And then
all right, so it has nothing to do with sea level at all then, because 203 is a wild number, right?
It does. It's not a wild number, but it has nothing to do with sea level. That 200,003 has nothing to do with sea level at all. None.
Yeah, it's just a triangle in a vacuum based on the distances.
Yes.
According to the globe idea.
No, according to that.
Based on the distances gotten from the globe model, yes.
Oh, okay.
So it's
All right,
circular
now you
again, but
understand it
like
probably more
he
than
can't help himself.
I know.
Well, the distances for it to be flat would have to be massive orders of magnitude wrong for at least for this thing to be lattice work of vertices that lie flat on a plane. Like, they would have to be really, really wrong because it's not even close.
Wait, so you're talking about height instead of distance?
Height relative
no,
to
he's-
each one of the
he's
points of
saying-
the tetrahedron.
Yeah, he's saying distance, Helio. That's all he's thinking about. He's thinking about distance, but because of the distances and the globe distortions, it creates a tetrahedron. And so the height of that tetrahedron, because of the distortions, make it so that he thinks that means the Earth is a globe.
You have to pretend the Earth is a globe for that shit to even work, just like Aristophanes bullshit.
No, you just have to do the math.
Yes,
Create
you
the
do.
tetrahedron.
Yes.
Well, you
yes.
get the
The answer
numbers
is
from the
yes.
globe, so that's where you get them
Yeah.
from.
You
Both
have
of
to
those-
pretend it's a globe first, bro. You have to accept this. You have to pretend the Earth is a globe first.
No,
and
you could
then
Sorry,
you
sorry.
assume the numbers.
Sorry, you could go into this believing that the Earth is as flat as a pancake, capture these distances.
That's not
Why
what.
do you keep saying flat as a pancake, Ray?
Yeah.
Because the shape is not.
We don't have actually a shape claim to the entirety of the world. That's what your side, which hasn't actually backed up that claim. We just have measurements and evidence that the foundation of your claim is false.
Right. I mean, you have to assume the Earth is a globe for those numbers that you put up. Yeah, I was
No,
confused at first.
Hold on a second. If I took this exact, I'll just one more time. If I took all these exact distances.
Are you about to post the same bullshit again? Are you about to do that?
If you take if you remove the cities' names and give this to, say, a high school student who's studying math,
Hey, let's do Chicago, Atlanta, frickin' Santiago, and fucking Johannesburg.
I'm sorry.
How about that? Let's do that and see if it works out.
Let me try to finish my point here. If we take the distances right here and remove all of the cities, and we just gave a high school class students side A, side B, side C, and the distances from the center out, and removed all of the city information and asked them to calculate what would the height be given these distances with no city names attached to them.
What are you talking about? Elevation above sea level, correct?
No, I'm not. If you
What do you mean by height then? You said you just said height.
No, yes, exactly. If you remove
height.
Yeah, right.
Okay.
And you're gonna plot them on a globe, right? When you present.
No. Let's just
you're not.
completely forget about the globe right now. Just if you let me finish my example, it will make complete sense. Don't think about the world, the globe, cities, or anything else.
Are you using instruments to measure something?
No, you're giving a math problem to high school students. That's it. That's all we're doing. It's just giving them a simple math
Oh
problem.
my God. See, he started with this bullshit. And now we're fucking 3 hours later with this nonsense.
So I can't finish the example. This is a pretty short example. It's a pretty short example, but you guys, I feel like you don't want me to finish. All right. So,
No, I don't want
finish, Ray, but it's irrelevant. On you go.
You haven't completed
All right.
anything.
All right,
You
I
haven't
made my
completed-
point. I'll shut up. You guys fucking have at it.
So if you give these numbers to any high school class that's studying geometry and say, and you say solve for the apex given side A, B, and C with a connected point of D in the center, they would use these same equations and come up with that the 200,003 at the bottom. Even in the complete absence of the idea of a globe or cities or distances, just simple math.
What are you talking about, Ray? How would they ever come to 203,000 meters above another city?
They're not. It's not above a city to them. They're just working with numbers. You could take kilometers off from it. Just take kilometers off from it. If you just ask them if this distance, if this vertices is 9,200 and vertices B is 7,730 and vertices C is 6760, and vertices out from the center to each of those is 46, 58, 39. What would be the height of the apex at point D? And they would come up with the answer.
Yeah, and you have a ball. You have a ball to begin with.
Ray. So you plot four points on a piece of paper.
Yep.
Each point has a general difference, a minute difference in height relative to the other.
Nope.
And you're going to solve for 203,000 meters in the center point, the fourth point.
Lord have mercy. No, that's not what I'm saying. I'm saying if you gave a high school student a question on a test and said, these are the lengths of three sides of a triangle, and these are the lengths of the vertices from a point that's center to each one. Given the length of those vertices, how high is the apex of point 4?
What do you mean
Great.
high? What the hell are you talking about?
How were the vertices measured? Thank you very much.
In this case, they're not measured. They're just numbers that a teacher would have given to math students.
Yeah, made up about something that you're going to place onto a ball later. Yeah, we get it.
No, we're not talking about a ball. We're just talking about math.
Yeah, we are talking about.
What we're trying to do.
No, you're talking about ball math. You're talking about making triangles and then placing it on the geoid.
You don't even have a triangle to begin with, Ray, when you're considering a globe. So.
Yeah, there's no triangles in high school math. I've never seen one. Give me a break. Are you fucking serious?
No, these distances that you plot on a globe.
You are retarded.
These are curved lines.
They're not distances in my example. They're just numbers. They're just numbers.
Hey guys, could I butt in for just a sec?
Sure.
Can you hear me? Hey, what's up?
It's up to me.
How's it going, Sonny? What's up, Jace? What's up, everybody?
Hey, how's it going?
Long time. I was listening on YouTube and I heard this guy. It sounded like he might get yelled off, or like he was starting to make comments like, "You guys don't want me to finish," or something like that. And it's gonna, I just didn't want him to leave before I understood exactly what he was trying to say, or if somebody here could explain besides him exactly what his point is about this, I'd be interested, because I know that he's going to probably find out that, that it doesn't really prove what he's saying, but I don't want him to just leave without it being like, shown that we understand what he's saying, or I don't know.
Yeah.
And then why is it that it needs to be a globe? You just talk about elevations. Like, what are you talking about? It a completely flat Earth, or is it misunderstanding of like that Earth doesn't have topography if it's a flat Earth? We have topography.
I'll tell you.
No, not quite. Not
I'll
quite.
tell you. He basically took the distances from a globe Earth projection, like for instance Google Earth, between a bunch of cities, and then plotted it out, and then that created a triangle. And based on that triangle, he thinks that the elevation of the middle city inside that triangle is much higher than the other ones. But in reality,
so we need the ball. We need the ball to make that much higher for it to be that way. Okay. So the middle of the
reasoning. Straw man. With the ball and
straw
ending
man.
with the ball.
Okay. Well then,
straw man.
If you misunderstood him, let him explain why you misunderstood him. Go ahead.
Man. Yeah. I'm saying that in. Hold on 1 second. I got to send a message to someone real quick because there's something going on here. But I'll try to answer your question as best I can. All right, they're taking care of it. Okay. So what I'm saying is that if there's such a thing as a tetrahedron, it's basically a pyramid with three sides, right? So we've all seen pyramids. And so when you form a pyramid, what it is you have a triangle as a base. And then you have an apex above that's raised up. So it creates this 3D shape called a pyramid. And you can actually figure out if you give math students the lengths of all of those vertices, in other words, the lines that connect each of the angles, if you give them
4 points with one in the middle.
Yeah, there's 4 points with one in the middle, so there's 6 vertices. So if you give a math student the lengths of the 6 vertices, they would be able to tell you.
There are 4 vertices on a pyramid.
Let me see what I'm doing here. A tetrahedron, though, not a pyramid, right? So we're talking about specifically.
Well, pyramid is a kind of tetrahedron.
Yeah, and there should be 6 vertices, right?
Well, you're wrong.
6. No, I'm looking at the shape right in front of me. There's 6 vertices.
Okay, well, you're wrong.
Well, I mean, I don't know. I can't argue with that one because it doesn't make any sense to me. That's I'm literally counting them. Sorry. So anyway, new perspective.
Petra, 4 sides. 6. Okay.
Well, but that's not. I want to hear his point though. If he thinks he's on a, if he really thinks he's, if this is like the one thing that makes him think he's on a ball. I wonder why it's such a strong argument. in his head.
So yeah. Okay. All right. Thank you. So if you take if you give math students the lengths of all of those vertices and how they connect in the angles, and ask them what the height, it would be able to give you the height of the apex, in other words, the top point of this tetrahedron or pyramid, through just using normal math. Like they would be able to figure that out. So
it's not uniquely determined because the apex you projected onto the base triangle. Where is it falling?
Well,
you can move it. You realize you can move the apex, right? So that's projection.
Yeah, you can move in 3D space. You can move the apex around.
Yes.
But once you do that, you have to change the length of one of the vertices.
Yes. So which apex are you measuring, and why are you measuring an apex?
All right. So what in this particular case, we would be measuring an apex. Let's just say the apex is D, but we have points A, B, and C are the base. So there's A, B, and C as the base. It creates a triangle, flat triangle, right? And then you give the lengths of each of those sides of the triangle. So the student will know the length of each side.
Okay.
Then you say from point D, there are vertices that connect out to points A, B, and C, and you give the lengths.
D is where? D is in the triangle on the plane?
It's in the center of the triangle.
What's the center of the triangle?
It's the point that rests in between points A, B, and C.
That's not uniquely determined. Do you mean the centroid?
Can you post the proof that you're talking about, whatever it is? I don't have a reference to look at.
And there's no height. You're working in the plane, just to be clear. There's no tetrahedron. You're in 2D right now.
In 2D right now.
Okay, 2D. So there's no tetra and there's no height. Okay, got it.
Well, no,
so be clear. So don't say you're a tetrahedron. Don't try to say words. You don't know what they mean. You're working in a plane right now.
Tetrahedron, by the way, has 4 vertices.
Yep.
Or that's
and pyramid's 5.
Yeah. So is it 4 vertices? Okay. So say there's 4 vertices.
Okay, but we're not even talking. We're working on a plane. We're just working with some point inside a triangle. Got it. So
what we're working with the lengths between those points. That's all we have. We're not giving the students anything else. They don't have the angles.
Where do you get those lengths?
In this particular example, they can be completely arbitrary. The teacher can just make up the lengths.
But so which point are you taking?
What proof to the Earth being a ball?
Anything. You're trying to explain your globe proof.
Yeah, give specific cities, specific lengths, exactly what you're talking about, so that we have a reference of why it is you're convinced that this overrides all the other things that make it obviously stationary and level.
All right, just check out the chat I just posted.
Are you a math teacher, by the way?
No, I'm a soccer coach. That don't work for a school. Well, I'm an analytics strategist. That's what I do for a living. How
long have you looked into the topic that we're talking about here? Have you looked into it at all? Have you considered it?
Well, even if I started yesterday, the proof is what it is. I just posted it.
No, I'm talking about flat Earth.
Yeah, one of my best friends and I have been discussing this for, I would say, approximately 2 years.
Is he a flat earther?
Oh, yeah.
Oh, okay, so you're trying to. Did you try this with him? Was he convinced by this proof?
I only just recently relayed this to him, and we haven't had a chance to discuss it yet.
Okay. Because there's a lot of things about these measurements, spherical access and all that. That's completely fallacious. You know that, right?
None of that is accommodated in here. It's just the measurements of creating a tetroid based on the distances, all the distances between the 4 points. That's it.
If you're an academic guy, though, I would recommend if you go to the section. I created this section in here called Brenner Comps. I think they named it. Somebody help me name that. Brenner Comps. He's a mechanical engineer, and he studied mechanical engineering and linguistics at the University of Vienna. And he's like a scholar that's been, flat smacking people on Quora since 2016, and I just recently discovered him. And other people haven't even heard of him. Most everybody hasn't, but he breaks down the math and all kinds of stuff. Like for the professor in you should definitely check out why he's sure that we're not on a ball. I mean, this might be just tiddlywinks compared to what he's saying.
Yeah, that I haven't seen this stuff, and so maybe this is all child's play. And this actually, this little tetrahedron proof using the lengths of these sides, there could be a massive error in this. Like I could be completely wrong about it, because I'm not a math guy. I'm not a geometry guy. It's not what I do.
I'm gonna put the link. I'm gonna put the link for that section, and you could just click that hashtag Brenner where I just posted it there, and it'll take you to I made 80 comps of his stuff. He goes into other interesting things as well besides flat Earth. But
I'm looking
check out all that information, and he goes into the math and all kinds of stuff that might satisfy someone like you. I'm sorry to interrupt the whole conversation though. If you want to continue with your proof, I don't know why that. I mean, a lot of it's been reverse engineered at the very least. So they may actually have some of these heights, worked out so that if you check to see if you're on a ball, they could say, "Oh yeah, you're on a ball because of this." The height here would be this much higher, but I mean, come on, sea level. We're talking about sea level, bro.
Mm-hmm.
How can we have sea level on a ball? Think about it.
I mean, in this particular example, I'm not contending with that particular issue. So
I know. But what about your friend? How did he become a flat earther? If you're still friends with him, did you guys have a problem at first? Were you kind of just gonna disown him?
No, we have no problems in debating this at all. In fact, we rather enjoy it. So
that's good. Because most of my friends won't even talk to me about it. They started by laughing at me, and now they're just running away from me, which is most of our experience. So it's good that you're at least willing to actually have it out with them.
No, he's
most
a good
people
friend.
won't even discuss it. That's good.
Well, within my inner circle, I only have a few close friends, and he's one of them. So we don't have any problem talking about this, and we go back and we have for a couple of years, and it's when we're face to face, it gets a little heated, but I mean, it's all in good spirit. It's not.
Well, you're still convinced completely that you're on a ball, or are you starting to kind of warm up to the idea?
No, I don't see any reason to think I'm on a flat Earth. It looks like I'm on a ball to me.
It looks like it. Well, I mean, think about this, okay? If you be honest, which you probably will be. So you sound sincere. You were born on this Earth without anyone ever saying anything about the globe Earth, right? No theories. You've seen no information about that. You just rightly assume it's stationary and level, right?
That's correct. Yep.
So then why would you say it looks like you're on a ball Earth?
Yeah, I remember this to this day. It was actually before I even started kindergarten. My older brother, who was really into space and things like that. I remember this argument to this day, even though I was only 5 years old. Him trying to convince me that the Earth was round and me being really resistant to the idea. And then eventually, once I started looking at enough stuff, it just kind of made more sense to me. For whatever reason, it just made more sense. So
but that's different than saying it looks like you're on a ball, which is what you just said. It doesn't look like you're on a ball.
Well, yeah, I mean, I guess this was the same question that we had earlier tonight. So now we're getting back. We're retreading some of the topic. And I know that, I know you and I haven't talked yet. I've only been in this server, the Discord server, for a couple of days, and I have to get up early tomorrow, so I'm gonna have to bail here real quick. But just
at least you sound sincere.
I'm not. I'm not.
We get a lot of people that aren't. Broker. That's good. That's in your favor.
No, I'm not. I'm an honest broker. Now I might be what everyone keeps calling me, what a fucking retard. I think that's what they call me mostly. So that might be true, but I'm
well,
but
no,
I'm an honest one.
You don't sound retarded. You may say retarded things, but I don't think you're retarded.
That seems to be the common thing.
No, go ahead, though.
Me. No, so I guess
it doesn't look like you're on a ball. You could take that back. It seems like we're on a stationary level plane.
Not a ball.
Otherwise, the server wouldn't exist. If it didn't seem that way, flat Earth would be done, right?
I would put it this way: what I have a choice to, and when I'm looking up at, say, the night sky or during the day, and I see the stars or whatever going around me, I just have a choice to make. I have a choice to make that either I'm on a stationary Earth and all of these things are rotating around me because they do appear to move in kind of a circular rotation motion, like that's the path they seem to be following, according to my eyes. Or I choose to believe that I'm on a rotating platform that makes all of those things appear as though they're rotating around me. So in my opinion, I'm taking the latter, not the former. I believe that the platform is spinning.
Okay, so you're on a platform instead of a ball now.
I mean, I could get to the ball, but I'm saying you're asking me what I think and why I see it. That's the way
But you're
I see
choosing,
it.
but the thing is that like if you're saying there's two viable options there, either the sky's moving or you're moving, well then okay, let's say that there's two equally viable options. Now the fact that you have no sense of it or no direct experience of a ball makes me think, why wouldn't you sway towards the other viable option that goes along with everything you experience?
It seems to me less likely that all of these objects are flying around me in circles, because I just don't experience stuff going in a circle in front of me in my own day-to-day life. It just doesn't happen.
That's likely that you have no feeling of being on a ball, no sight of curvature whatsoever, but it's more likely that because the sky moves, you're on a ball. And you're going in different, like, at different speeds around the sun, traveling with the sun at 500,000 miles an hour, displacing yourself in space and time by 12 million miles every day. Also, swirling the Milky Way at millions of miles. I mean, it's just, the claim's ridiculous. The extraordinary claim doesn't have the extraordinary proof.
Yeah, I mean, I don't know if I want to go down all of the things because you mentioned many, many things. But yeah,
well, I mean, it's just a barrage of things that you have to accept that you're on a ball and you're acting like it makes more sense.
I would put it this way. I don't think that you are irrational for what you believe.
No, it's not about belief. Flat Earth isn't a belief. If I'm going to leave here too, but if you could just get one thing from me at least, Flat Earth isn't a belief. It's the loss of a belief. Once you give up the idea that you're on a ball, it's just like you admitted. You would assume, rightly so, that you're on a stationary level Earth before the whole ball belief came around. That's the belief that fucked everything up. Now they have to call Flat Earth a belief. Flat Earth was never a belief before the ball Earth belief came along, because they're saying your reality is the opposite of what it seems. You don't have to believe you're sitting in a chair. If you're sitting in a chair, you're sitting in a chair. It's your base axioms, right? If you're on a stationary level Earth, that's a base axiom of your experience. Now, if there's reason to believe other than that, then great. But we thought there was, and there isn't any longer.
Yeah, fair enough.
Us. So it's the loss of a
fair
belief.
enough.
That's all I'd like to get through to you on my end.
Yeah, fair enough. All right, I'm checking out, guys.
You too.
Appreciate
Take
the
care.
combo. Yeah, have a good one, guys.
What is your profession?
See, old friend, I brought more soldiers than you did.